Good evening, everyone. We'll wait for 2 more minutes to start our session. Okay, good evening, everyone. Advanced Happy Independence Day wishes. Let us continue our session. Yesterday, we started with some applications of this topic, Fourier transform. First, we discussed a distortionless transmission, where we observed that magnitude spectrum is constant for all frequency, phase spectrum is linear function of frequency. Magnitude spectrum is constant, phase is linear. Then we discussed that phase delay and group delay formulas. Phase delay and group delay formulas. Later on, we discussed that interlinked concept, Hilbert transform, pre-envelope and complex envelope. Then we started with autocorrelation and cross correlation. So, how we define the autocorrelation function of an energy signal, sir? Rx tau equals to Rx tau. If you go for energy signal, what is the definition? Integral of xt into x of t minus tau dt. If the considered signal is complex, we may use conjugation. For a power signal, we have written that as what? Limit t tends to infinity by 2t integral minus t to t xt into x conjugate of t minus tau. So there we discussed the time domain approach and frequency domain approach for most of the examples. Okay. What are certain properties of autocorrelation we consider is autocorrelation at origin corresponds to energy or power in the signal. Autocorrelation at origin corresponds to energy or power in the signal. Then we stated it is an even function of tau. Real signals, if the considered signal is real signal, directly even function of tau. But if the considered signal is complex signal, then we have to take conjugate symmetry concept. Conjugate symmetry. For periodic signals, how to obtain the autocorrelation function means by using Fourier series spectrum. Rx tau Fourier series is a Cn into Cn star. That is what mod Cn square in the case of cos function I consider. But if you go for cross correlation function of xt and yt, in the case of periodic functions, I am saying, sir, in the case of periodic function, Rxy tau, if we represent modulus of Cn square, indirect meaning is what? Cn into, if you represent Rxy tau, it is like Cn star into Dn. Ryx tau means Dn star into Cn. That star indicates signal may be complex. Signal may be complex. Then we discussed for energy signals how to get the answer without using the definition. See the cursor, without using the definition, by using property x of tau convolved x minus tau, signal convolved by folded. So what is the basic difference between convolution and correlation, we said? What is the basic difference between convolution and correlation, we said? Without folding, convolution is treated as correlation. Without folding operation, convolution is treated as correlation. Some models we solved, some examples we solved on that concept. Okay. Let us discuss few more examples on this concept. Let us discuss few more examples. Normal convolution requires folding, shifting, multiplication and integration, sir. But in correlation, there is no folding operation. Without folding, convolution is treated as. And another point we observed is autocorrelation is always function of the lag parameter, amount of delay. You are taking xt or yt, answer is written in terms of tau, the amount of delay. It is also called as setching parameter. What for you are setching? What is the amount of delay that is caused between the signals? What is the amount of delay that is caused between the signals? Let us continue examples. Everyone study the question and try to answer it. Consider a filter with frequency response 1 by 1 plus j omega. Input signal is e power minus 2t ut. Find the energy spectral density of output. We want output spectral density. We have written theoretically output spectral density is nothing but input spectral density multiplied by squared magnitude spectrum. Output spectral density is nothing but input spectral density multiplied by squared magnitude, that is mod x omega whole square into mod h omega whole square. Input spectral density we have taken as what? Fourier transform. Everyone tell me what is the Fourier transform of decaying, sir? E power minus 2t ut means what is the Fourier transform? 1 by 2 plus j omega whole square. 1 by 2 plus, what is h omega Fourier transform? 1 by 1 plus j omega, that is simplified as 1 by 4 plus omega square into 1 plus omega square. 1 by 4 plus omega square into 1 plus. Output spectral density is nothing but input spectral density multiplied by squared magnitude spectrum mod h omega whole square. Output spectral density is input spectral density multiplied by squared magnitude spectrum mod x omega whole square into mod h omega whole square. That is the first bit asked. First bit asked. Filter response given, input given, we want the energy spectral density of output. Filter response is given, input is given, we want the energy spectral density of output. Output spectral density is input spectral density multiplied by squared magnitude spectrum. Think about the second bit also, those who have completed the first one. It is asked that show that the total energy in the output is 1/3 of input energy. By knowing output spectral density, how to get output energy, sir? In the example, we know output spectral density. So how to get output energy? Area under spectral density. Area under spectral density. Correct or not? Area under spectral density is energy. So to answer the second bit, energy in the output equals to 1 over 2 pi integration of output spectral density. Area under spectral density corresponds to energy in the signal. Parseval's theorem only. Area under spectral density corresponds to. It means we have to integrate this. So partial fraction enjoyment. If you take partial fraction omega square plus minus 4 means it becomes minus 1 by 3. Omega square plus minus 4 means omega square plus minus 1 means it becomes plus 1 by that quantity we have to integrate. So minus 1 by 3 by omega square plus 4 one quantity, 1 by 3 by omega square plus 1 another quantity d omega. Of course, it is looking like which standard formula, sir? Integral 1 by x square plus a square dx means 1 by a tan inverse x by a. Integral 1 by x square plus a square means 1 by a tan inverse. By using that, we can simplify. Simplify and tell me what is the answer. Output spectral density means once we got output spectral density, how to get output energy? If you want to find the autocorrelation also, again you should convolve XT and HT, then on RY0. Any overaction is same only, bacha. After getting YT only, then you will know RY0. But here one hint is given for us. What is the hint is show that the total energy in the output is 1/3 of input energy. It means if you know the input signal energy, automatically you will know the output energy or not, sir? What is the input signal given? Decaying. Let me calculate input energy 0 to infinity e power minus 2t whole square dt. E power minus 2t whole square 1 by 4. Automatically this answer must be how much? 1 by 12. 1/3 of input energy is asked or not? 1/3 of input. Because that hint is given, I have calculated input energy 1 by 4. How did you get 1 by 3 there? The question asked like that, show that total energy in the output is 1/3 of input energy. Input energy 1 by 4. 1 by 12 can be written as what? 1 by 3 into 1 by 4. That is 1/3 of input energy. 1 by 3 into 1 by 4. 1/3 of input energy is output energy. In the question directly it is asked. It is not asked that find the energy in the output. Because it is stated, hint is available. Whatever the input energy that is there, it is multiplied by 1 by 3. Whatever the input energy that is there, multiplied by 1 by 3. One of our friend has asked what is the significance of spectral density. By knowing spectral density only, you are in a position to know how much of input information has retained exactly at the output side. Once you pass decaying exponential through the systems are 1 by 1 plus j omega, it is like RC low pass filter with time constant 1 second practically. RC low pass filter with time constant 1 second. So how much output energy is there? Only 1/3 of input energy means 33% of input energy has been retained. For that we are in a position to know spectral density. For that we are in a position to know spectral density. As it is stated in the second bit, show that energy in the output is 1/3 of input energy. For easiness, what I have done? First I calculated the input energy. Integral 0 to infinity e power minus 2t whole square dt, we got 1 by 4. So compulsory this answer must be 1 by 12. Compulsory the answer must be 1 by 12. Good. Most of you answered good. Everyone try this question, sir. Try this model. A signal g of t is given as e power minus t ut. It is stated in the problem that x of t is like gt convolved gt. X of t is like g of t convolved g of t. Y of t is correlation of g of t with itself. First it is stated x of t equals to gt convolved gt, which is treated as convolution term. Next it is stated y tau is correlation. Everyone recollect how we expressed the correlation in terms of convolution. What is the formula I have written first slide? Signal convolved by folded version. Signal convolved by, so g tau convolved g minus tau. G tau convolved g, that is correlation. With this information, try to answer those bits. With this information, try to answer those bits. 3 bits are given. First one is funny. He wants the value of xt at t equals to 1 by 16. Everyone recollect our convolutions there. Decaying exponential convolved by decaying exponential means, what is the answer we have written? E power minus at ut convolved with itself means t times e power minus at. So what is the answer? Where we require it? Substitute that instant 1 by 16 e power minus 8 by, that can be 1 by 16 root e, 1 by 16. Energy spectral density, energy spectral density, energy density spectrum meaning is same. At f equals to 0 also we want. Energy spectral density at f equals to 0. What is the meaning of energy spectral density, sir? Modulus of g omega whole square. Modulus of g omega, that is 1 by 8 plus j omega whole square. Answer becomes 1 by omega square plus 64. Magnitude whole squares. Fourier transform. We want that answer at f equals to 0 implies omega equals to 0. F value 0 means omega. What is that number? 1 by 64. 1 by 60. That is the second bit answer. Find the energy spectral density at f equals to 0. Magnitude whole square. First you obtain. Later on, substitute f place 0 or omega place 0, sir. Y tau at origin. What is the name of y tau in this problem? Autocorrelated signal at origin. Y tau at origin means indirectly ACF at origin, autocorrelation function. It means energy in the signal or not, sir? So Y0, it is named as Y tau as correlation result, energy in the signal. So what is the energy in the original signal? 0 to infinity, it is a positive side function, e power minus 80 whole square. Correlated signal at origin means energy, find out energy. Y g omega whole square है. अरे बच्चा स्पेक्ट्रल डेंसिटी बोले तो फोरियर ट्रांसफॉर्म होल स्क्वायर है ना. रेफरेंस सिग्नल क्या है? G of t रेफरेंस सिग्नल. So modulus of g omega whole square. Energy spectral density of given function. What is the given function? E power minus 80 ut. This is one technique to answer this, sir. Technique 1. Technique 2 is, in the second bit we know spectral density or not. Area under spectral density also represents what for us? Area under spectral density is also taken as energy in the signal. Even if you integrate this term, 100% answer is 1 by. As we know, energy spectral density in the second bit, area under spectral density means ACF at origin. Last technique here, tech 3. What is correlation in terms of convolution? Everyone see the cursor. What is correlation in terms of convolution? Signal convolved by folded version. What is the signal? E power minus 8 tau u tau convolved with folded version means e power 8 tau. We studied under convolution. Decaying convolved by growing is a two-sided exponential. Decaying exponential convolved by growing exponential is two-sided. Even yesterday also we solved a decaying exponential problem, sir. If you substitute tau place 0, again the answer is 1 by 16. There are 3 methods. One method, autocorrelation at origin is energy in the signal direct. Second method, area under spectral density also means energy in the signal. Y0 means autocorrelated signal at origin. Last method, signal convolved by folded version. Decaying convolved by growing exponentially is two-sided. Standard answer we know, tau place 0. Any technique result is same. Easy technique is first one. Y tau at origin is easy technique. Okay? Y tau at origin is easy technique. This convolution correlation comparison questions generally framed for instrumentation fellows in competitive exams. Instrumentation fellows got this type of models so many times, sir. Instrumentation fellows. We know correlation in terms of convolution is signal convolved by folded version. Decaying convolved by growing is two-sided. Here also tau place 0 means same number 1 by 16, sir. Okay. Make a try of this question. Find the cross correlation function of two signals, x of t and y of t. Both are decaying exponential means their energy signals are power signals. Both are given as decaying exponential means they are energy signals. Correct or not? They are energy signals. Cross correlation, how to solve easily? If it is Rx y tau, x of tau convolved y minus tau. If it is R yx tau, sir, y tau convolved x of y tau convolved x of signal convolved by folded version. That is what we said. X with y means x tau convolved y minus tau. Y with x means y tau convolved x of minus tau. After substitution, what is the enjoyment here? E power minus tau u tau convolved with e power 3 tau u of minus tau. Yesterday's last problem style, Gaussian functions. They are also energy signals. Yesterday's last example style. How you solve this by Fourier series? Bacha fellow, energy signal only for periodic signal you can take Cn. Fourier series. If you are in front of me, I would have thrown you. देखो signals क्या दिया? It is a periodic function. Cool brother. Anyway, if I take Fourier transform, I named a cross spectral density. That word, cross spectral density. Cross correlation Fourier transform. Auto correlation Fourier transform is energy or power spectral density. This is cross spectral. What is the Fourier transform? First terms are 1 by 1 plus j omega. E power a t u minus t means 1 by a minus j. So what is the partial fraction enjoyment here? Partial fraction. Decaying exponentially is 1 by a plus j omega. Increasing is 1 by j omega plus minus 1 becomes 1 by 4. J omega plus minus 1 becomes 1 by 4. J omega plus 3 means that is also j omega plus 3. So the inverse Fourier of each term is what's that? The inverse Fourier of each term is 1 by 4 e power minus tau u tau 1 by 4 e power 3 tau u of minus tau. First one is decaying formula, second one is increasing formula. Correct or not? This second one you try, every one of you know how to check whether your result is correct or wrong, sir. R x y tau answer must be equals to what? R yx of minus tau. Whatever R yx tau you will get in that place, tau is replaced as minus t means 100% it must be equals to this term. Otherwise, gone. Answer gone. First you solve for R yx tau. There tau place if you substitute minus tau, 100% you should get this answer. Okay. Independence Day emotional. We should be grateful to our motherland. Being an Indian, extraordinary. Of course, something we should do that is useful for everyone, sir, from our side. It will be mentioned, friend, whether it is asked as CCF of xt with yt means x with y. If it is asked cross correlation function of y with x means, it is neatly mentioned. They will denote the cross correlation function of rxy tau or ryx tau. Based on the question they have framed, they will mention the symbol for you. No problem. कोरोना ज्यादा लोगों को रोना दे के गया, फिर भी नहीं गया. Still they are struggling to invent the medicine. Okay. Take 5 minutes time, give me correct answer for this last model which I want to solve on correlation. Input sync T, sir. Sync pulse. What is the Fourier transform of sync function, sir? Rectangular spectrum. Which is the input to a system with frequency response 3 rect omega by 8 pi multiplied by exponential. Find the output energy. If you want to get output energy, compulsory we should know output spectral density. If you want to know output energy, compulsory we should know output spectral density. Enjoy. Everyone calculate output spectrum. Y omega first, sir. What is nothing but x omega into h omega? Input is sync 10t. It means sin 10 pi t by 10 pi t. This is passed through a system which is rectangular spectrum. What is the meaning of 3 rect omega by 8 pi, sir? Minus 4 pi to 4 pi. Minus 4 pi to 4 pi. It is 3 e power minus j2 omega. That extra exponential term is also. Calculate the output spectrum. Then you are in a position to know energy in the output side. Come on. 2 fellows have given correct answer. Yes. What is the spectrum of the input, sir? That rectangle covers from minus 10 pi to 10 pi with amplitude of 1 by 10. Recollect everyone, sin a t by pi t. Sin a t by pi t means rectangle from minus 10 pi to. So output spectrum is input spectrum multiplied by system response. When you multiply both rectangles, 3 by 10 e power minus j2 omega limited for which range? After doing multiplication, amplitudes are multiplied. They are limited for 4 pi range or 10 pi range, sir? Minus 4 pi less than omega less than 4. Minus 4 pi less than omega less than. Question is find the output energy. Energy in the output equals to 1 over 2 pi integral of mod y omega whole square so 1 over 2 pi integrate for the range minus 4 pi to 4 pi. We are taking magnitude. Don't forget that magnitude. So it is 3 by 10 whole square. Modulus of exponential is what? 1. Modulus of y omega whole square. Magnitude of this term becomes. Answer is 9 by 25 after simplification, sir. 9 by. Good. Most of you have given correct answer. Some of you have given confidently wrong answer. Like autocorrelation spectrum is power spectral density or energy spectral density cross two different signals. It is named as cross spectral density. Same use. I used a word that by comparing the input spectral density, output spectral density, suppose noise is added. In the output noise signal is there. How to suppress this? How to suppress that component means mod x omega square, mod y omega square, both quantities are compared, sir. For the range of frequency, they are matched signal. Otherwise, it is noisy content. In all problems we solved today, only 4 or 5 models we solved. Whenever you want to get output energy or output power, whenever you want to get output energy or output power, what we require first? Spectral density. Area under spectral density corresponds to energy or power in the signal. Area under spectral density corresponds to energy or power in the signal. This is modulus. Don't be tensed about exponential. Modulus of e power minus j theta is 1. So it is 3 by 10 whole square directly. Mod y omega. Mod y omega whole square, sir. Let us discuss the next concept. Fourier transform of periodic signals. Already we solved Fourier transform of periodic functions like cos and sine. Already we have solved them. But now we are finding out the generalized formula, how to get Fourier transform of any periodic signal. It need not be cos and sine always, sir. How to get Fourier transform of any periodic signal. Okay, listen first everyone. Any periodic signal means first we are writing the Fourier series representation. Any periodic signal means first we are writing the Fourier series representation. Sigma minus infinity to infinity Cn e power jn omega naught t. For that we want Fourier transform. Most of the fellows have a doubt that when Fourier series itself is representing spectrum, what is the need of again taking transform? In this expression, the term Cn, the amplitude of every harmonic that is in frequency domain. Only the term Cn, the amplitude of every harmonic that is in frequency domain, still the exponential corresponds to time domain, sir. How? Otherwise, how will write time equals to frequency? We are that much stupid, sir. Left side time, right side also time only. Only the amplitude of every harmonic, which is like impulsive spectrum, that is in frequency domain. See here, everyone. What is the Fourier transform? One we know. For one, what is the Fourier transform, sir? 2 pi into del of omega. If one is multiplied by exponential, then what is the Fourier transform? 2 pi into del of omega minus modulation property. Instead of omega naught, what we have here? Instead of only one omega naught, we have. So what is the Fourier transform for this complete expression means? Xp omega equals to 2 pi into sigma minus infinity to infinity Cn del of omega minus n into omega naught. 2 pi into sigma minus infinity to infinity Cn del of omega minus n into omega naught. This is the general formula we are using for finding the Fourier transform of any periodic signal. This is the generalized formula we are using for finding the Fourier transform of any periodic signal. From this expression, whenever you want to get Fourier transform of any periodic signal, what we have to know first compulsory? What we have to know? Fourier series coefficient. I hope everyone have remembered the Fourier series definition. 1 by t integral signal multiplied by exponential term. 1 by t integral signal multiplied by exponential. Once you calculate Cn for any periodic function, substitute here, that becomes the answer, sir. Once you calculate Cn for any periodic function, directly substitute there. Directly substitute there. Okay. Suffix P indicates periodicity. Don't be tensed for that. Suffix P indicates periodicity. 1 Fourier transform 2 pi del omega 1 multiplied by exponential means shifted modulation property. Instead of omega naught, here we have n omega naught. So this is the answer. If you want to get Fourier transform of any signal, any periodic signal, simply calculate what? Cn, substitute here, that becomes the answer. Okay. Suppose the question is find the Fourier transform of periodic impulse train. If the impulses are separated by Ts gap, what is the fixed Fourier series coefficient we have written? Please respond, everyone. What is the fixed Fourier series coefficient we have written when the impulses are separated with a gap of Ts? What is the Fourier series coefficient we have written, sir? Very good, very good. Most of you have answered. Cn is 1 by Ts or not, sir? Very good. Cn is. So, what is the Fourier transform of this periodic impulse train? Substitute in the blocked formula. See the cursor. Substitute in the 2 pi by Ts. Cn place 1 by Ts. Sigma minus infinity to infinity. Del of omega minus n into. So in the frequency domain also, we are retaining impulses. In the frequency domain also, we are retaining impulses with a gap of omega naught, with a gap of weight of each impulse is 2 pi by Ts. Weight of each impulse is 2 pi by. This point theoretically we have learned already. For a periodic impulse train, spectrum is another impulse train. For a periodic impulse train, spectrum is another impulse train. We are repeating the same point again. But from this example, we have to check one property. What is that is? Discrete or sampling in one domain will cause periodic nature in other domain. When you take discrete form or sampled form in one domain, it will cause periodic nature in other domain. Okay. How Cn is 1 by Tsr? Arey bacha, same problem is studied in Fourier series na. Substitute karo either 1 by Ts integral 0 to t impulse multiplied by exponential, which is based on shifting property. Integral becomes 1. What is the reference signal? Del t. Del t e power minus j n omega naught t becomes 1. 1 by Ts we are left with. See, sir, this signal we have taken in sampled form, which are periodically repeating. Here spectrum also periodically repeating in sampled form. Here periodic becomes here sample becomes here periodic. But in this example, both properties are combined. Both properties are. So periodic and sampling in one domain corresponds to periodic and sampling in one domain corresponds to what, sir? Sampling and periodic in other domain. Sampling and periodic in other domain. Because of this statement only, we are learning the last chapter DFT, discrete Fourier transform. Discrete or sample meaning is same here. Periodic and sampling in one domain corresponds to sampling and periodic in other domain. Okay. Please don't put a double arrow there. Right, double arrow means domain conversion. Don't feel if I put double arrow, it is Fourier spectrum. Arey bacha. Discrete in one domain will cause periodic nature. Periodic in one domain will cause discrete in nature. What is there? Fourier series, you have learned periodic signals. Spectrum is not discrete. Spectrum is discrete or not? Before giving session, you cross check your basics. Okay. So periodic and sampling in one domain corresponds to sampling and periodic in other domain. Periodic and sampling in one domain corresponds to sampling and periodic in other domain. The weight of each impulse here is 2 pi by Ts, sir. Weight of each impulse here is 2 pi by Ts. Why we are doing Fourier trans means C and amplitude of every harmonic is in frequency domain, still exponentially is time domain. For that we are finding the spectrum to distribute. That you will know in sampling theorem derivation. Last 2-3 days, what formulas we studied is, let me say theoretically, mathematically, I hope some of you are perfect. A rectangle in one domain corresponds to SAP function or sinc function in other domain. When you take rectangular pulse in one domain, other domain, what will happen? SAP function or, when you take a symmetrical triangle, what we got, sir? SAS square or sinc square. SAS square or impulse in one domain becomes constant in the other domain. Correct or not? Gaussian. What is the spectrum of Gaussian? Again, now we have taken impulse train. Again, what is the answer? Another impulse. We have given our more concentration towards which function? Rectangle in one domain becomes SAP function or sinc function in other domain. Correct or not? Rectangle in one domain corresponds to SAP function or sinc function in other domain. First habituate theoretically. Rectangle in one domain corresponds to SAP function or sinc function. Symmetrical triangle means SAS square or sinc square. Impulse means constant. Constant means impulse. Gaussian is Gaussian. Impulse train is impulse train. This is what I asked you multiple times. What are the two signals for which we always feel time domain, frequency domain? Answers are same, sir. What are the two signals for which I always feel time and frequency domain? Solutions are same. Gaussian function as well as impulse train. Time domain, frequency domain representations, they will look like same. Time domain and frequency domain representation. Correlation of discrete signals I will discuss. Don't get emotion, bacha. DTFT. Still we are in continuous form only. Discrete time Fourier transform. Still I have not started. There I will discuss. I know what to teach. After writing the exam, you will know what I discussed in entire signal subject. Before that, don't get emotion. Follow the class thoroughly first. Now we studied correlation of continuous signals only. Discrete signals still we have not entered, sir. DTFT, all that. Once time comes, I will discuss. Actually, signals and system subject is like musical notes. For fun, I am saying, like Sarigama Padanisa. First we have SA. Rectangle can be treated as Re. Gaussian can be treated as what? Ga. Sa, Re, Ga. Still, other notes I am finding out how to create. SA function is treated like Sa. Rectangle is like Re. Gaussian function what? Ga. So when you are listening to music, you should feel you are listening to signals only always. Okay? Be thorough with these relations especially. I will try out with SS Taman. Good, good. I'll ask that bacha. He can create anything. Very good copy, master. Maffer modulation theorem. Oh. SS someone has SS in him. Great joke, great joke. Maybe he's copying from our class notes only, bacha. Okay, jokes apart. Let us discuss the next application and most important one, sampling theorem. Sampling theorem. Good. So much creativity you are showing rather than formulas. Remembering the relation, Parseval's theorem bole to pa. Very good, very good. Very good, excellent. First, we are discussing the sampling theorem concept for band limited signals. Listen here, everyone. The first form of sampling which we are discussing is called as ideal or instantaneous sampling. Ideal or instantaneous. Then we are discussing the practical form of sampling, that is called as natural and flat top. One is natural sampling concept, sir. Another one flat top. Flat top. So all these are considered for band limited signals. Where the low frequency may be zero, band limited signals. Ideal or instantaneous sampling, natural flat top. Okay. There is a separate concept, sampling of band pass signals. In comparison with low pass sampling, with reduction in the sampling rate, we are in a position to sample the band pass signal also. In comparison with the low pass sampling which we are learning, we can reduce further the sampling rate in the case of band pass sampling. Most of you are aware, in the process of converting continuous to discrete, sampling rate must be greater than or equals to 2 times highest analog frequency. Okay, that condition only we are learning. To get this statement, so many fellows have worked for more than 40 years in AT&T lab, American Telephone and Telegraphy, Blackman, Nyquist, Shannon, Whitaker, Coyle-New, all these team of members. They have worked around 40 years. How to store the data in easy manner, where sampling is needed, wherever you want to store the information, first continuous signal must be converted to discrete or sampled form, and another advantage, it is used for multiplexing concept. Another. So many members have worked, but finally only 2 fellows got their name in the history, Nyquist and Shannon. Shannon-Hartley law, channel capacity, which we are learning in communication, Shannon-Hartley law. Okay, let us discuss in detail. First, we are discussing the concept of ideal sampling. Listen, everyone. First, we are discussing the concept of ideal sampling. Actually, I want to tell you one point. First, we are passing the continuous signal through C to D converter, continuous to discrete. That point only today we are learning. Sampling concept. Later on, this X of n data is passed through a digital filter. Digital. So finally, it must be given to D2C converter to recover back continuous output. This is what the new topic added for ECE, discrete time processing of continuous signals. In classroom, I used to discuss this and this. This is extra added. It is not a big deal. That also you are going to learn. Okay. Continuous to discrete converter is what? Sampling theorem only. How to convert continuous signal to sample form. Digital filters we use it to learn in DTFT, jet transform also. So now opposite D2C converter is also asked. This is what discrete time processing of continuous signal, the additional topic added. Today our concentration is only the first black box, C2D converter, where we are using different forms of sampling, sir. Where we are using different forms of sampling. Okay. What actually we are doing in ideal sampling is take an arbitrary signal x of t which is there for all time. Arbitrary means no specific shape. Take an arbitrary signal which is there for all, no specific shape it is having. How to take the sampled form of the signal means multiply the signal with the train of impulses. Multiply the signal with the train of impulses. When you try to take product of these two, sir, whatever the resultant signal we are getting, it will look like original analog signal graph only, but it is retaining only the amplitudes of the original analog signal as weight of the impulses now. The signal is retained only at impulsive instants. The signal is retained only at impulsive. What we learned in the first class, sir? To convert continuous to discrete signal, we need a simple switch that opens and closes for every TS second. It is a sampler device which have spacing of TS units. Okay, it is a sampler. So here X del T is called as the ideally sampled signal. X del T is called as the ideally sampled signal, which is nothing but product of X of T multiplied by this impulse train can be represented as this summation, sir. This impulse train can be represented as this summation xt into del of t minus nts. Xt into del of t minus. Let us take Fourier transform for this expression. What is the spectrum of this one? So you can feel these two signals as product of two signals. Multiplication in time domain means what will happen in frequency domain. Multiplication in time domain corresponds to convolution in. So 1 over 2 pi x1 omega convolved x2 omega. Frequency convolution property. Multiplication in time domain corresponds to convolution in. So x of t is like x1t, impulse train is like x2t, sir. So what is the Fourier transform? X del omega equals to, for x del t I am representing x del 1 over 2 pi x of t means x omega convolved. What is the impulse train Fourier transform? Just now we have defined, sir. For periodic impulse train, what is the Fourier transform? Everyone see the cursor. 2 pi by ts sigma del of omega minus n omega naught. That you substitute. 2 pi by ts sigma del of omega minus n into omega naught. Xt Fourier transform is like x omega. Impulse train is this 2 pi jump. Any term convolved by impulse means it is shifted by that much amount or not. So what is the new relation? 1 by ts sigma minus infinity to infinity x of omega minus n into, that is the spectrum of sampled signal. It is the spectrum of sampled signal from which we are deciding the statement of the theorem. From this mathematical expression, we are deciding the statement of the, it is the spectrum of sampled signal. It is the spectrum of sampled signal. In this expression, omega naught is the sampling rate. What gap to be provided, it is decided by omega naught number, sir. What gap to be provided. Everyone see here, in the process of converting an arbitrary signal, no specific shape, in the process of converting a continuous signal to sampled or discrete signal, what we have chosen? Periodic train of impulses, such that we got the signal. The weight of each impulse here is amplitude of the analog signal at that instant. The weight of each impulse here is amplitude of the analog signal at that instant. When you want to obtain the spectrum of this, multiplication in time corresponds to convolution of the spectrums. So x omega convolved by this term means it is shifted by that much amount. From this expression, we are deciding the statement of the theorem, sir. Everyone just go through the steps first. Go through the steps, sir. That is a spectrum of sampled signal from which we are deciding the statement of the theorem. Okay. One by TS multiplier also has significance. Don't neglect that. 1 by TS multiplier also has significance. We cannot neglect it. From x del omega expression only, we are deciding what is the statement of the sampling theorem. From x del omega expression only, we are deciding statement of the sampling theorem. How 2 pi by Ts है? इधर क्या है? For periodic impulse train, what is x omega? Answer we have written 2 pi by Ts sigma del of omega. Same expression I am using just 10 minutes before it happened. For impulse train only, we have taken spectrum 2 pi by Ts. Yes. But as we want this condition in frequency domain, and we know a signal cannot be time limited and band limited simultaneously. A signal cannot be time limited and band limited simultaneously. For proving this theorem, we are assuming some reference spectrum, sir. For proving this theorem, we are assuming some reference spectrum. Assume a band limited spectrum. Assume a band limited spectrum. I am assuming a triangular spectrum as reference. I am assuming triangular spectrum as reference. Why we are assuming triangular spectrum as reference means no specific reason. You can take your own spectrum, it must have band limited nature. This right side I have sketched 2 spectrums, this way also you can take. You take your own spectrum as reference. There is no specific reason why we are taking triangle as reference. Okay? For proving the theorem, we require some reference spectrum that we are assuming as triangle. You should take the spectrum that its maximum energy must be concentrated within the low frequency region. So what is the bandwidth of the spectrum, sir? Omega m. But what is the spectral width? What is the spectral width here? 2 times. As a signal cannot be time limited and band limited simultaneously, for proving the theorem, try to assume a band limited spectrum. Try to assume a band limited spectrum. Okay. Now our job is relating omega naught in terms of omega m. Relating omega naught in terms of, whenever we are relating 2 parameters, there are 3 chances: greater than 2 omega m, equality, less than 2 omega m. Whenever we are relating two parameters, there are three chances. Listen first. First one is called as oversampling. Second one is called as critical sampling. Last one is called as undersampling. In all the three cases, we have to check that whether the spectrum of sampled signal is retaining this information or not. In all the three cases, we have to check that whether spectrum of sampled signal is retaining this information or not. That point we have to check, sir. Okay. Let us start with the first case. Listen carefully. If you take omega naught greater than 2 omega m, for sketching the spectrum, I am assuming omega naught equals to 3 into omega m. So, what will happen to this expression, sir? If I substitute omega naught as 3 omega m in equation 1, what will happen to that expression? 1 by Ts sigma minus infinity to infinity x of omega minus 3n omega m. Directly omega naught place what we substituted? 3 into. So how we are going to visualize the graph? Let us verify. How we are going to visualize the. Listen. If I take n place 0, it is simply x omega or not. If I take n place 0, it is simply 1 by Ts extra scaling factor multiplier. N plus 1 means same spectrum right shifted by how many units, sir? 3 omega m units. N plus 1 means same spectrum right shifted by. N plus 2 means same spectrum right shifted by. Like that there is repetition. Similarly on the left side. Similarly on the. Why the triangles are repeating here means just now we have stated it. Sampling in one domain will cause periodic nature in other domain. What is the nature of X del T, sir? It is looking like samples. Nature of X del T is samples. Sampling in one domain will cause periodic nature in other domain. When you are proving the theorem for single message spectrum, why you want to repeat this information means this repetition arrangement is made for multiplexing concept. Don't have a wrong thought. Theorem is proved for single message spectrum. Why you want to repeat it? This repetition arrangement is made for multiplexing. When we are using FDM, by tuning to different frequencies with a different signal which we are transmitting the signals. When we are taking frequency division multiplexing, by tuning to different frequencies, we are transmitting different signals of different bandwidths. So this repetition arrangement is made for multiplexing. It is incorrect to think that when we are proving the theorem for single message spectrum, why the repetition is needed. Repetition is for multiplexing because you don't know at the respective frequency shift which signal spectrum is needed, sir. At the second shift, you may want first signal spectrum. At the third shift, you may want fifth signal spectrum. We don't know that. That is the reason repetition arrangement is done. So why spectrum of sample signal contains repetition means repetition arrangement is made for multiplexing. Repetition arrangement is made for multiplexing. Don't forget that point. Okay. Listen. What does the spectrum of sampled signal contains means original spectrum as well as shifted replicas of that one. Original spectrum and shifted replicas of. Are we losing any information here? You go anywhere, our original information, original spectrum is retained as it is or not, sir? Of course, we are providing some gap that is called as guard band. Between the repetition of the triangles, we are providing some gap that is called as guard band. What is the purpose of providing this gap is to recover back our original spectrum as it is. To recover back our original spectrum as it is, whatever the filter we are designing at the receiving end, it will ask for some more extra width. That is the reason this gap is provided, that you are going to understand in few minutes why this gap is needed. To recover back our original spectrum as it is, whatever the filter we are designing at the receiving end, it will ask for some more extra width. Okay, it will ask for some more. But one question for you, Bandwidth of the original spectrum is omega m. Then why I have taken that 2 multiplier here? You should relate sampling rate directly in terms of omega m only. Why I have taken that extra 2 multiplier? I want the reason, sir. Why that 2 multiplier is needed? Why that 2 multiplier is needed? Come on. What is the purpose of taking that extra 2 multiplier? The reason for that is to avoid overlap. It is not spectral width. In this case, I assumed omega naught as 3 omega m. See everyone. In this case, I assumed omega naught as 3 omega m. So what is the before frequency? Omega naught minus omega m. If these two triangles are overlapped, loss of information is there or not? If these two triangles are overlapped, loss of information is there. So images do not overlap under the condition. Images means repetition of the spectrums. They are not overlapping only when omega naught minus omega m is greater than. This frequency must be more than this frequency. Then only there is no overlap of triangles. So images means repetition of the spectrums. Images do not overlap under the condition this frequency is more than. After simplification, you are going to get omega naught greater than 2 omega m. 2 is not because of spectral width, that is wrong thinking. To avoid overlap, that is the minimum width to be maintained. To avoid overlap. The last observation is, what is the guard bandwidth in terms of sampling rate? What is the guard bandwidth in terms of sampling rate, sir? This minus this is guard bandwidth. Means omega naught minus omega m minus omega m. Omega naught minus omega m minus. So it becomes omega naught minus 2 times omega. How to write guard bandwidth in terms of sampling rate means this minus this, omega naught minus omega m minus omega m. Okay. So in the first case, there is no loss of information. What points we checked? The spectrum of sampled signal contains original spectrum and repeated version of the spectrum. Why the triangles are repeating means, just now we studied sampling in one domain corresponds to periodic nature in other domain. Repetition arrangement is made for multiplexing. Repetition arrangement is made for multiplexing. The second observation which we have made is, second observation, sir. Why the 2 multiplier? Why the 2 multiplier means the two triangles are not overlapped when you obey this condition. Last observation is, what is the guard bandwidth in terms of sampling rate? Guard bandwidth in terms of. So in the first case, there is no loss of information. When you take oversampling, there is no loss of information. When you take omega naught greater than 2 omega m, there is no loss of information. What is the second case we can take here, sir? Omega naught exactly equals to 2 times omega m. Second case we can take here is omega naught exactly equals to 2 times. Then x del omega becomes what? 1 by ts sigma minus infinity to infinity x of omega minus 2n. Directly omega naught place we are substituting omega 2 omega m. Directly omega naught place we are substituting 2 times. Now, what will happen to the spectrum graphs? Without any gap, the triangles are repeated or not? Without any gap. N value 0 means original spectrum as it is. N value 0 means original spectrum as it is. N value 1 means same triangle right shifted by 2 omega m units. Next it is right shifted by 4 omega m units, like that. Without any gap, the triangular spectrums are repeated. Without any. So second case also there is no loss of information. Second case also there is no loss of information. So over sampling there is no loss. Critical sampling also there is no loss of information. Okay. But when you try to take the last case, omega naught less than 2 omega m. Let us assume sampling rate equals to just omega m, which is less than the mentioned value. What will happen to the formula then? Spectrum of sample signal 1 by Ts sigma x of omega minus n into omega m. Directly omega naught place we substituted omega m, sir. Directly. Without confusion, I am sketching individually. If I take n value minus 1, it is x of omega plus omega m. Means where original triangle covers are left shift of omega m units. Left shift. N value 0 means our original spectrum as it is. N value 0 means our original spectrum. N value 1 means original spectrum right shifted by omega m units. Original spectrum right shifted by, like that. How many such triangles we can take, sir? On the screen I have shown only 3, but how many such triangles? N varies from minus infinity to infinity. After addition of all these triangles for different frequency ranges, how the resultant graph will appear? Here I have shown only 3 triangles, but n varies from minus infinity to infinity. N varies from minus infinity to, how the resultant graph will appear? Come on. How the resultant graph is going to appear? Positive ramp added to negative ramp. Here negative ramp added to positive ramp constant. Negative ramp added to positive ramp constant. Because it is happening for infinite length, resultant graph is a constant. Resultant graph is constant. Correct or not? So here we lost the information that is called as aliasing or spectral folding. Aliasing or spectral folding. Here we lost the information. Aliasing or spectral folding. Aliasing meaning is high frequency components taken on the identity of low frequency components. In the sampled spectrum, high frequency components taken on the identity of low frequency components is called as aliasing. The other way to understand, the component which is not present in the signal spectrum has appeared in the sampled spectrum. In our derivation, what is our original spectrum, sir? Triangular information. But what we have retained? Constant we have retained. The component which is not present in the signal spectrum has appeared in the sampled spectrum. Original information replaced by new information. For that, the easy word is alias. Original information is replaced by new information. Okay. Simple way to understand the word alias. All our pet names at home are alias names. This is an easy example I will give for understanding purpose. We have a original name but with nickname also. Generally at home they will call with us nickname. Chinny, Bunny, like that. Correct or not? So all our nicknames that are used at home are alias names. Original name replaced by new name. So original information is replaced by new information here. Original information is what? Triangular information. But what you got? Constant you got. The component which is not present in the signal spectrum has appeared in the sampled spectrum. The component which is not present in the signal spectrum has appeared in the sampled spectrum. Original information replaced by new information means. Original information replaced by new information means it is called as aliasing. So to avoid this problem, what always we have to satisfy, sir? The first two conditions only. Greater than 2 omega m, no problem. Equality also no problem. So to avoid aliasing this problem, to avoid aliasing, what we have to do? Sampling rate must be greater than or equals to 2 times omega m. Sampling rate must be greater than or equals to 2 times omega m. Omega m meaning is highest analog frequency. Never use the word bandwidth. In our derivation, bandwidth is a correct word because we started at 0. But for a given signal, suppose you have taken one signal with frequency 10 Hz and 100 Hz. 10 Hz and 100 Hz. You cannot take 100 minus 10, sir. 2 times 100 you should take. Okay. So 2 times highest analog frequency is the correct word. 2 times highest analog frequency is the correct word. Everyone listen here. Even we have shown this much emotion till this minute, saying that this is a condition to be satisfied. Practical cases, this condition is not satisfied. Practical cases. Sampling rate greater than or equals 2 times highest analog frequency is not directly satisfied. The reason is, when you are designing any instrumentation amplifier, that is called as data acquisition system, sir. They will ask sampling rate of less than 500 Hz. I am giving some practical examples for you. Digital control systems, digital controls, they are asking sampling rate in the range 1K to 5K. But if you take DSP and digital communication, the latest equipment may ask for more than 20 megahertz. If you want to maintain that much sampling rate, indirectly increase in the channel width. Increase in the channel width means paying more money. Increase in the channel width means paying more money. That is not only the reason why this condition is not satisfied directly, means we proved this theorem under what assumption? What is the assumption we have made, sir? Band limited spectrum. No spectrum in real time is band limited. It is impossible to generate infinite length signal. This arbitrary signal, I said infinite length. It is impossible to generate infinite length signal in time domain. It is impossible to generate infinite length signal in time domain. All real world signals are finite length signals. Can you speak without break for half an hour? Not possible. All our real world signals are finite length signals. It means if you take finite length in time domain, automatically spectrum is of infinite length. If you are taking finite length duration signal in time domain, infinite length. But our theorem is valid for which spectrums? Band limited spectrums. So what is the cure? How to avoid the problem? Before passing the continuous signal through, a sampler, in the process of converting the to discrete signal, use a low pass filter. That will suppress the high frequency components of the signal message spectrum. Okay. Technically, this is called as anti-aliasing filter. Anti-aliasing filter, technical, which will suppress the high frequency components of the signal spectrum. As no spectrum in real time is band limited, to make infinite length spectrum as band limited spectrum, first continuous signal is passed through low pass filter such that sampling can be done easily. Rather than wasting more money for the channel width, according to these examples, rather than wasting more money for channel width, with the same cost, 100 such low pass filters can be designed with the same cost. So mathematically to solve problems, first expression useful, sir. Practically always we are using second technique. One example to say, assume you want to sample a rectangular pulse. No problem, finite length signal. Signal is finite length in time domain. But what is the spectrum of that one, sir? Rectangle in time domain corresponds to SAP function or sinc function in frequency domain, which is infinite length. How to make this as a band limited spectrum means try to design the low pass filter with cutoff frequency, main lobe width. Main lobe width as the cutoff frequency. Automatically it is retaining only this information. We proved maximum energy or power is there only in the low frequency region or not. So to make this infinite range as finite range, design this low pass filter with main lobe width as the reference cutoff. Automatically this information is retained, which is looking like a band limited spectrum or not. So practically second case is used. Mathematically to solve first case is used. Mathematically to solve the problems, first case is used. So the point you should understand here is what? Note. What is the note to be observed? No spectrum in real time is band limited. So to convert infinite length spectrum, so to convert infinite length spectrum as band limited spectrum, continuous signal is passed through. Continuous signal is passed through low pass filter before sampling. Continuous signal is passed through low pass filter before. In a single line, why low pass filter means to suppress the high frequency components of the signal spectrum. In a single line, sir, why this filter, low pass filter is needed means to suppress the high frequency components of the signal spectrum. Everyone recollect PCM, pulse code modulation. What are the block diagram of, what is the block diagram of PCM, sir? Low pass filter, sampler, quantizer, encoder. Low pass filter, sampler, quantizer, encoder. So why that extra low pass filter means? To make infinite length spectrum as what? Band limited spectrum. To make infinite length spectrum as band limited spectrum. Don't forget that. Okay. In real time, no spectrum is band limited because all real world signals are finite length signals. So to make infinite length spectrum as band limited spectrum, what we are using? Try to use this low pass filter, which will have less cost rather than maintaining more channel width to have sampling rate like this. To have sampling rate like this. Main observation here is greater than or equals to means is it minimum required or maximum, sir? Greater than or equals to means minimum sampling rate required is called as Nyquist rate. Minimum sampling rate required is called as Nyquist rate, which is 2 times highest analog frequency, which is 2 times. In terms of F symbol, if you want to write 2 times FM, 2 times. What is Nyquist interval means? What is Nyquist interval? TS equals to 1 by Fs. Nyquist interval is TS is 1 by. Greater than or equals to means it is the minimum sampling rate, Nyquist rate. Minimum sampling rate greater than or equals to means it is a minimum sampling rate required, that is called as, which is 2 times the highest analog frequency. 2 times the highest analog. You have chance of converting a continuous signal to discrete or sampled signal without loss of information only when omega naught greater than or equals to 2 times omega m. Be careful. Nyquist rate is different, sampling rate is different. Don't mix the words. Nyquist rate means 2 times highest frequency. Sampling rate may be more than value, more than this number or less than this number. Nyquist rate, sampling rate words, don't mix them. Nyquist rate means minimum sampling rate required, 2 times highest analog frequency. But sampling rate can be any number, more number, less number also. Okay. Practically, second technique is used. As no spectrum is in real time is band limited, to make that as finite length spectrum, continuous signal is passed through low pass filter. Its job is suppress the high frequency components of original signal spectrum. Suppress the high frequency components of the original signal spectrum. Okay, let us solve some models related to Nyquist rate concepts. Some simple questions. Think and answer me. Very simple models. We'll discuss. Find the Nyquist rate and Nyquist interval for the given signals. Nyquist rate and Nyquist interval. First signal is sine 200 pi t by pi t. Sine 200 pi t by pi t means what is the Fourier transform of that one, sir? What is the Fourier transform? A rectangle that covers from minus 200 pi to 200 pi. A rectangle that covers from minus 200 pi to, what is the highest frequency it is having? 200 pi. 2 into 200 pi radians per second. My laziness, I will write like that. Or domain hertz. 200. What is Nyquist interval? 1 by 200 seconds. 2 times highest frequency. Highest frequency is 200 pi or not? F domain omega to F conversion means divided by 2 pi. 200 hertz. Nyquist interval becomes 1 by 200 seconds. In Nyquist plot, you are not doing any sampling, brother. He has invented, but you are not doing any sampling there. Take the Fourier transform of SAP function sin a t by pi t, rectangle 2 times the highest frequency. 2 times the highest frequency. What is asked in the second bit, sir? Square of the first signal. Square of the first signal, SAS square. For SAS square, one technique, triangular spectrum. SAS square function corresponds to triangular spectrum because it is indirectly convolution of 2 equal length rectangles or not. Convolution of 2 equal length rectangles becomes triangle. This is one way. Our numerator, what is sin square theta expansion? 1 minus cos 2 theta by 2. Numerator sin square theta is 1 minus cos 2 theta by, such that the highest frequency is 400 pi. 2 into 400 pi radian. 2 into 400 pi. F domain 400 hertz. F domain 400 hertz. SAS square triangular spectrum on logic. SAS square triangular spectrum on logic. Or expand sin square theta is 1 minus cos 2 theta by 2, highest frequency 400 pi, another logic. Good. But what is the difference between first bit and second bit, sir? Because square is sampling rate doubled, 200 becomes 400 or not. If you take cube here, SAC cube type, sin 200 pi t by pi t whole cube means your answer becomes 600 hertz. If you take whole cube, sir, sin 200 pi t by pi t whole cube, answer becomes 600 hertz or not? It becomes 600 hertz. Okay. Third bit is given as 5 cos 1000 pi t into cos 4000 pi t. Cos A, cos B form. 5000 pi t into cos 4000 pi t means cos A, cos B form. Think and answer me. So I am not doing exact simplification. Cos A, cos B means cos A plus B plus cos A minus B. If we do addition, highest frequency 5000 pi, subtraction 3000 pi, which is highest, sir? 2 into 5000 pi radian. 2 into 5000 pi, or Fs equals to 5 kilohertz. Nyquist interval becomes 1 by 5 milliseconds. Nyquist interval becomes 1 by 5 milliseconds. Cos A, cos B, don't look for exact simplification. A plus B, A minus B, add them 5000 pi, subtract 1000 pi. Which is highest? 5000 pi is highest. What is the fourth bit asked? Decaying exponential convolved by SAP function. Decaying exponential convolved by SAP function sin at by pi t. Think. Convolution time, what will happen in frequency domain? Convolution time, what will happen in frequency domain? Multiplication. After multiplication of the spectrums, tell me what is the highest frequency. Fourier transform first term 1 by 6 plus j omega. We know when you draw the spectrum, it is of infinite range. When you draw the spectrum, it is of, that is multiplied by sin at by pi t spectrum means a rectangle from minus a to a. What is the product of them, sir? This is infinite range. This is minus a to a. After multiplication, that curvature is limited for what range? That curvature is limited for what range, sir? Minus a to a. With highest frequency as a, 2a radian, or a by pi hertz. Convolution time is multiplication in frequency domain. 1 by 6 plus j omega is Fourier transform first term. Sin at by pi t means rectangular spectrum. When you multiply both spectrums, highest frequency is a. Nyquist rate becomes 2a. Nyquist rate becomes 2a. Let me see how many of you will give correct answer for this question. If I give xt as modulus of sin t, a full wave rectified sine wave, mod sin t, I want the Nyquist rate, modulus of sin t, full wave rectified sine wave. We studied neatly full wave rectified sine wave contains only even harmonics or not. I don't expect you have remembered that formula. We defined the Fourier series coefficient something like this. Only for even harmonics, only even harmonics it contains. That is a word we used. It is not a band limited spectrum. Nyquist rate cannot be defined. It is not having a band limited spectrum, so Nyquist rate cannot be defined further. Where is the highest frequency? It contains infinite harmonics. There is no limit for that. It is not having a band limited spectrum, so Nyquist rate cannot be defined, sir. Your creation started. We observed full wave rectified sine wave contains only even harmonics. They are covering entire range, not band limited. Not band limited. What is our last example asked here? SA function convolved by periodic impulse train. SA function convolved by periodic impulse train. Every one of you know spectrum of both functions. Decide and tell me correct answer. SA function convolved by periodic impulse train. Why is wrong? Think. Not possible. That is also wrong. I am not asking a sync question. That sync 100t, 3 sync square 60t. Either देखो. SA function multiplied by periodic impulse train. This is like del of t minus nts form 10, such that omega naught is 2 pi by 10. Means pi by, once you take Fourier transform, sir, first rectangle covers from minus pi by 2 to pi by 2 with amplitude 2 into, we have so many impulses which are spaced with what gap? 5 by 5 gap. We have so many impulses which are spaced with 5 by 5, 0, pi by 5, 2 pi by 5, 3 pi by 5, like that. We clearly know Any term multiplied by impulse means impulse will be retained. Product property of impulse. Any term multiplied by impulse means impulse will be pi by 2 indicates 0.5 pi, 2 pi by 5 indicates 0.4 pi. Next number 0.6 pi, don't consider. After multiplying rectangle with impulses, impulses will be retained. Automatically, what is the highest frequency we have? What is the highest frequency after multiplication? 2 pi by 5. Nyquist rate becomes 2 times highest. 4 pi by 5 radian. So 2 by 5 hertz. 2 by 5 hertz. Okay. 2 times highest analog frequency. 2 into 2 pi by 5 means 4 pi by 5, sir. Rectangle multiplied by these impulses means impulses only. Product property of impulse. Product property of impulse. Any term multiplied by impulse means impulse will be retained. This is pi by 2 means 0.5 pi. 3 pi by 5 is 0.6 pi. Gone. After making product, you are left with till 2 pi by 5 only. Acha. Middle I left one bit na. That is bacha. Sync 100T means 100 pi is the frequency. Everyone see here. Sync 100T means 100 pi. Sync square 60T means 120 pi. 60 pi square doubled. So automatically what is the Nyquist rate? 2 into 120 pi radian. Take highest. Here 100 pi, here 120 pi. 2 into 120 pi. RF domain 120 hertz. 120 hertz. Sync 100T after expansion 100 pi, sir. 60 pi square means 120 pi. 2 times highest. 2 times 120 hertz. Just a minute. Enjoy this question. A signal x of t is having Nyquist rate as omega naught. Find the Nyquist rate for each of the following signals. If original signal Nyquist rate is omega naught, how to get the Nyquist rate of the individual signals? Nyquist rate is given for us directly, sir. Nyquist rate omega naught. Nyquist rate omega naught means you can feel highest analog frequency is half of that, because 2 times this value is Nyquist rate, answer or not? 2 times. Tell me what is the Nyquist rate of xt plus x of t minus 1, sir? No change in the width of the spectrum. Xt Fourier transform x omega, here also x omega into exponential. There is no change in the width of the spectrum means Nyquist rate remains same or not? Nyquist rate remains same or not? Come on. So first signal Nyquist rate is same omega naught. Here x omega, no change in the width of the spectrum. D by dt xt Fourier transform is what, sir? J omega into x omega, again Nyquist rate remains J omega into X omega. Think about X of 3t. Think about X of 3t, sir. What is the answer? Omega naught by 3 or 3 omega naught like that. Tell me. X of 3t in the time domain is compression. Compression in time is expansion in frequency. Everyone see here. If you are assuming like our original spectrum, if you are assuming like original spectrum X omega, what is the Fourier transform of X of 3t, sir? 1 by alpha X of omega by alpha. Now the triangle covers what range? Minus 3 omega m to 3 omega m. There is increase in the width of the spectrum or not? Nyquist rate becomes 3 into compression in time is expansion in frequency. Compression in time is expansion in frequency. 3 into omega m is the answer. Means 3 times omega naught. Last one, xt into cos omega naught t. Xt into cos omega naught t. Come on, last bit. Highest analog frequency for x of t we observed as omega naught by 2. Beginning. Cos function has highest frequency of omega naught. Highest analog frequency of the original signal omega naught by 2. Cos function has omega naught. Multiplication in time, cos into cos style, what we have done in the previous question. Multiplication in time means a plus b, a minus b. If you do addition, it will be highest frequency. First I am writing signal frequency 2 times, that is Nyquist rate or not. Signal frequency here omega naught by 2, cos function frequency omega naught. Omega naught by 2 plus omega naught, that answer becomes 3 into. Even you apply band pass sampling concept, answer is same. But here our original signal is a band limited signal. Don't be tensed. Let xt is a signal with Nyquist rate. Once I discuss band pass sampling, apply xt cos omega naught t band pass sampling concept, 100% same answer. 3 into omega naught only. But our original signal is a band limited signal. Okay. Let me see. Same problem. What is the Nyquist rate of this one? Xt convolved x of t by 2. Come on. Same problem. What is the Nyquist rate of xt convolved x of t by 2? Convolution in time is multiplication of the spectrum, sir. Convolution in time is multiplication of the spectrum. Again, I am taking this as reference spectrum. What is the Fourier transform of x of t by 2? 2 times x of 2 omega scaling, such that the triangle covers for minus omega m by 2 to omega m by 2. If I multiply both the spectrums, what is the highest frequency I can have? If I multiply both spectrums, highest frequency omega m by 2. So highest frequency here for this convolved signal is omega m by. Already what is omega m in the question, sir? 2 times this is Nyquist rate. So what is the answer? 2 times this. After multiplying both spectrums, highest frequency omega m by 2. Omega m in the question already we know as omega naught by 2. 2 times this is Nyquist rate. Answer or not? Be careful with convolution. Don't get emotion. After convolution in time, multiplication of the spectrums. When you multiply both spectrums, highest frequency limited to omega m by 2. In our question, omega m is already omega naught by 2, sir. In our question, 2 times this is Nyquist straight answer. Okay. Think about this question. Two signals X1T and X2T are band limited to 2 kHz and 3 kHz. Band limited to word means FM is given or FS is given. Band limited to means FM is given or FS is given. Respond. Only FM, highest analog frequency present, band limited to X1T, X2T. Their FM value band limited to means first one 2 kHz, second one automatically what is the Nyquist rate they require? What is the Nyquist rate of each one, sir? 2 times highest means 4 kHz and 6 kHz respectively. Then we should get Nyquist rate of this combination of signals. Tell me everyone. What is the Nyquist rate of X1 of 2T? 2 times original, answer or not? 8 kilo. 8 kilo means 8 kHz. 2 times original Nyquist rate. Compression means expansion. What is the Nyquist rate of X2 of T minus 3? Come on, friends. When you are shifting the signal, Nyquist rate not affected. 6 kilo. When you are shifting the signal, Nyquist rate not affected. C bit X1T plus X2T means 2 kHz signal added to 3 kHz means which is highest? You can feel one is a 2 kHz sine wave, another one 3 kHz sine wave. Which is highest? 2 into 3K, 6 kHz. 2 kHz sine wave added to 3 kHz sine wave. Next it is given as X1T multiplied by X2T. Now we are multiplying 2 sine waves. 2 plus 3, 2 minus 3 are the chances. 2 plus 3. So highest frequency 2 into 5K. 10K is the answer or not? Highest frequency 2 into 5K. X1T convolved X2T. Convolution in time is multiplication of the spectrums. Convolution in time is multiplication of the spectrums. Think of and tell me. Think of and tell me. Good. Convolution in time corresponds to multiplication of the spectrums. Here it is stated one signal band limited to only 2 kHz, sir. Rough graphs I am sketching. Another signal band limited to 3 kHz. After multiplication of the spectrums, you can feel which is the highest frequency after multiplication. 2K means Nyquist rate is 4 kilo or not. When you multiply both the spectrums, highest is 2K, 2 into last bit. X1T has 2 kHz frequency. Cos 1000 pi t means 0.5 kHz. 500 Hz means 0.5 kHz. See the cursor. X1T has 2 kHz, sir. Cos 1000 pi t means 0.5. Product means addition. Product in the time domain like this, addition. 2 into 2K plus 0.5K. After addition, 2.5K means 5 kHz. 5 kilohertz, sir. Suppose in the same problem, it is stated like this. If the signal X1T is sampled at 1.8 times the Nyquist rate, find the sampling rate. If the signal X1T is sampled at 1.8 times the Nyquist rate, then find the sampling rate means what you have to say, sir? Original Nyquist rate of X1T, how much? See the cursor? 4 kilo. Then sampling rate is 1.8 into 4, 7.2 kilohertz. Don't mix the word Nyquist rate and sampling rate. Sampling rate can be any number. Nyquist rate means least minimum sampling rate required, sir. Okay, you must be careful. If it is mentioned, if the signal X1T is sampled at 1.8 times the Nyquist rate, what you have to take? Original Nyquist rate of X1T, 4K, 1.8 into 4 becomes how much? 7.2 kilohertz. So whenever we want to find the Nyquist rate, what is our job, sir? 2 times highest analog frequency. Be careful with convolution, everyone. Convolution time is multiplication of the spectrums. After multiplying the spectrum, check for highest frequency, sir. Be careful. Product in time, why we are adding means it is like two sinusoids. Sine into sine or sine into cos means what you will do? 2 sin A cos B or 2 sin A sin B, A plus B, A minus B. इसीलिए ऐड कर रहे. When you are taking product in the time domain indirectly, two sinusoids, A plus B, A minus B concept. Okay. Let us answer this model. A signal x of t equals to cos 10 pi t is ideally sampled at 15 hertz and the resulting samples are passed through an ideal LPF, low pass filter, with FC equals to 12 Hz. What frequencies will appear at the output of the filter? It is a regular gate exam question, regular model. You can keep any number of stars. Question statement is always like this only, sir. Question statement. Number game. Numbers may differ. We have taken a continuous signal as cos 10 pi t that is sampled at 15 hertz. Sampling rate is given as 15. Later on, the resulting samples are passed through ideal low pass. What is ideal low pass filter? Rectangular spectrum with cutoff 12 Hz. What frequencies are present at the output of the filter? Standard question. Okay. See here. Let me represent the given data in block diagram form. Cos of 10 pi t is one given signal. In our derivation triangular spectrum, we have taken passed through sampler. What is the sampling rate mentioned? 15 hertz. Omega naught becomes 30 pi radian mode. 2 pi fs. Later on, it is passed through ideal low pass with cutoff. What is the cutoff number? 12 hertz. So if I take omega c symbol, it becomes what? 24 pi. 24. We want frequencies at the output of filter. What frequency numbers are retained? See, to answer this question, the first observation is, as cos function is sampled, it is going to shift the spectrum for integer multiples of 30 pi, like in our derivation. In our derivation, spectrum of sampled signal 1 by Ts means x of omega minus n into omega naught. Our assumed spectrum is gone shifted by omega naught. Correct or not, sir? Our assumed spectrum is gone shifted by. Listen first. Cos 10 pi t Fourier transform is what? Every one of us know pi into 2 shifted impulses or not. It means signal frequency is plus or minus 10 pi. How you can find out the frequencies at the output of sampler? How you can find out the frequencies at the output of sampler? Omega minus n into omega naught. Don't draw the spectrum, because it is shifting this by integer multiples of omega naught or not. It is shifting our original spectrum by n varies from minus infinity to plus infinity. We know omega number, we know omega naught, n also known. Solve for that numbers. If I take n0, simply omega plus 10 pi minus 10 pi. If I am taking n value once, omega minus omega naught means plus or minus 10 pi minus 30 pi. That is giving us which number? Minus 20 pi. If I take n as minus 1, substitute here n as minus 1, omega plus omega naught means same numbers becomes positive 20 pi. But if I take n place 2, sir, omega minus 2 omega naught, that is plus or minus 10 pi minus 60 pi. Minus 50 pi minus 70 pi not needed, because what is the cutoff number we have? 24 pi is cutoff. For n equals to 2, we got more than that number or not? Try to find out the frequencies at the output of sampler. Omega number known, omega naught number known, omega minus n into omega naught, n plus 0, n plus 1, plus or minus 1, plus or minus 2, like that. Which frequencies will be retained at the output of the filter? Plus or minus 10 pi as well as plus or minus 20 pi. Plus or minus 10 pi, plus or minus radian mode, hedge scale 5 hedge and 10 hedge. 5 hedge and. So the only observation you should make in this question is what? How to find out the frequencies at the output of sampler without sketching spectrum. How to find out frequencies at the output of sampler? It is decided by which term, sir? Omega minus n into omega naught. What is omega meaning? Our original signal frequency plus or minus 10 pi. What is omega naught meaning? Sampling rate. Generate that numbers. Try to take the frequencies which are less than cutoff number. Okay, very simple question. You tell me, in this example we have done oversampling or undersampling. Very good. Most of you have answered. Good. We have done oversampling or undersampling, sir. Oversampling. Required Nyquist rate. Everyone see this graph. 2 into 10 pi, 20 pi is needed. But what is the selected number? 30 pi. Oversampling is done. 2 into 10 pi, 20 pi. Selected number is 30. Suppose that fellow has added cos 10 pi t plus sin 12 pi t. Then what is the enjoyment? In this problem, cos 10 pi t plus sin 12 pi t is added. What is the enjoyment? You should generate two combinations. Two frequencies are there means omega 1 minus n into omega naught, omega 2 minus n into omega naught. Two combinations you have to generate, sir. It becomes two combinations. Okay. Just you have to remember how to find out the frequencies at the output of sampler. That is decided by which term? Omega minus n into omega naught. Omega minus n into in one of the gate paper, old paper of course, same question is asked, sir. But he wants to know the exact answer. First, everyone solve the previous question. Solve the previous model. Your main observation is how to find out the frequencies at the output of sampler. That is decided by omega minus n into omega naught. Omega minus n into omega. Good. Oversampling. In one of the gate paper, same question is asked this way. He wants to know exact answer, not frequencies. Previous problem, what we have done? Only find out the frequencies. But now what is asked? Exact filter output. Make a try. Half problem is same here. Cos 10 pi t plus pi by 4. I have given cos 10 pi t. That fellow has added extra phase angle. Sampling rate, same number, 15 Hertz. Later on, it is passed through a filter. What is the filter expression given, sir? Sin pi t by pi t cos 40 pi t minus pi by 2 modulator. Previous example, we have chosen ideal low pass. Sin pi t by pi t means every one of rectangle covers from minus pi to pi. It is right and left shifted by how many units now, sir? 40 pi units. It is right and left shifted by 40 pi. Ideal low pass filter converted to ideal band pass filter. Ideal low pass filter converted to ideal band pass system with amplitude, magnitude level 1 by 2. I will add phase angles directly in the answer. I am showing only mod h omega. I will add phase angles directly in the answer. Till here, the problem is same as previous question only. See here, cos 10 pi t sampling rate same, but here extra phase angle is added. So frequencies at the output of sampler is same. Instead of ideal low pass, what is the system now we used, sir? Ideal band pass filter. Mod h omega I have taken. Phase angles I will add in the problem. Okay. Why 1 by 2? Xt cos omega naught t spectrum divided by 2 will be there or not? Xt cos omega naught t means divided by 2. See the funny thing. A sinusoidal input will guarantee what output for us? A sinusoidal input to LTI system will guarantee sinusoidal output. Choice is between A and C. Choice is between A and C. But filter is passing only which band? 39 pi to 41 pi. Automatically, what is the answer? Without solving only, you can say the answer. Sinusoidal input will guarantee sinusoidal output. Choice is between A and C. But filter is passing which range? 39 pi to 41 pi. Chance for 40 pi. Everyone see our previous slide. Frequency at the output of sampler, do we have 40 pi or not? Do we have 40 pi or not, sir? Let me explain how we got that numbers. Everyone see here. the filter output becomes 15 into 1 by 2 into cos of 40 pi t plus pi by 4 minus pi by 2. Input signal has phase angle of pi by 4, system has phase angle of minus pi by 2, they are added. 1 by 2 is the magnitude response of the filter. From where 15 came, just recollect our derivation. In the beginning of the derivation, each triangle peak amplitude, how much we have chosen, sir? 1 by Ts. Each triangle peak amplitude we have chosen as 1 by Ts, sir. So whatever may be the signal you are taking, that 1 by Ts will be multiplied or not. What is 1 by Ts means? Fs, 15. 15 is from 1 by Ts tag. 1 by 2 is from mod h omega. 40 pi is the frequency retained. Input phase angle, system phase angle, both are added. Which is first option? Which is half problem already we solved. Frequency at the output of sampler contains 40 pi or not. Just the phase angles are added. Just the phase angles are. Instead of ideal low pass filter, which filter is used? Ideal band pass. That is the reason I stressed it. Don't neglect 1 by Ts. Problem is gone. Don't neglect 1 by Ts, sir. It will be there. You must be careful. From where 15 came? 1 by Ts. See our derivation. Each triangle peak amplitude level, how much I have chosen? This 1 by Ts tag or not? Based on that only this answer. Based on that only this answer, 15. 1 by 2 is the magnitude of the filter. Phase angles are added always. Phase angles are. Okay. Take 20 minutes break. After that, we'll continue. Take a break of 20 minutes, sir. Okay. I hope everyone came back. Let us discuss one more model. Suppose a signal phi cos 400 pi t is given, sir, which is passed through sampler having sampling rate of 300 Hz. Later on, it is passed through ideal low pass with cutoff frequency 150 Hz. Find out the frequencies at the output of the filter. Number. Phi cos 400 pi t means what is FM value? Plus or minus 200 Hz. Plus or minus. Sampling rate is given as 300 Hz. Sampling rate is given as. So find out. How we can find out the frequencies at the output of sampler? Frequencies at the output of sampler is obtained as Fm plus or minus n into Fs. Instead of omega minus n into omega naught form, we can say Fm plus or minus. I am using plus or minus in the middle because n is varied from minus infinity to infinity or not? N is varied from minus infinity to. Solve and tell me. Come on, solve and tell me. First, find out the frequencies at the output of sampler. Find out the frequencies at the output of sampler. Fm is plus or minus 200 plus or minus n into 300. So if I take n value 0 plus or minus 200, no chance. N value 1 will create 500 and 100. N value 2 can create, substitute n place 2, sir. 800 and 400 plus or minus will be there. Don't be tensor for that. So n value 2 is outside the filter cutoff. Only 100 Hz is retained or not? Only 100 Hz is retained. In this case, it is undersampled or oversampled. In this case, is it undersampled or oversampled, sir? Required Nyquist rate is 400 Hz. Required Nyquist rate is 400 Hz. But what is the number we have chosen? 300 Hz means it is undersampled. That is the reason we got Eliezer component. This is Eliezer frequency. Our original signal doesn't have 100 Hz. Our original signal frequency 200 Hz. Because it is undersampled, we got Eliezer frequency or not? We got Eliezer frequency. Required Nyquist rate 400, but what is the selected number in the problem? 300 Hz means undersampled. That is the reason the output of the filter contains 100 Hz, which is not present at the input side. Input side, our frequency, original signal frequency is what? plus or minus 200 Hz. Plus or minus 200 Hz. How to understand this word aliasing in a better way? See here. See the graph, everyone. A sine wave of 7 kilohertz sampled at a rate of 6 kilohertz. First graph I have chosen 7 kilohertz sine wave sampled at 6 kilohertz. So sampler output contains which components? Fm plus or minus n into Fs logic. It is 7k plus or minus n into 6k. 7k plus or minus n into 6k. Means we have original 7 kilohertz as well as 1 kilohertz also. So thick one is 7k, light version, gray color, light version is 1 kilohertz. I have placed the Eliezer sine wave on the original wave. When you are finding out the sampled form of that signal, sir, n into ts means as the sampling rate is 6 kilohertz, it is like n into 166 microseconds. You are picking the samples on the time axis for every 166 microseconds. Which are these dots? Which are these? On the 7 kilohertz sine wave, I have drawn 1 kilohertz wave, which is the Eliezer wave. Computer is picking the samples of the discrete signal, but computer cannot differentiate this red sample. Whatever I have taken, this red sample is due to original 7 kilohertz sine wave or 1 kilohertz sine wave. There is no mechanism in the computer that can detect that whether the sample is obtained due to original 7 kilohertz sine wave or 1 kilohertz Eliezer wave. Suppose it is due to original 1. Suppose this sample is picked due to 1 kilohertz Eliezer wave, sir. How computer can recognize that it is due to original message signal? So that is the reason always oversampling is done. That is the reason always oversampling is done. Lower case also I have chosen another example, a 4 kilohertz sine wave sampled at 6 kilohertz only. That is the reason you got minus 2 kilohertz as the Eliezer wave. So this is the better way of understanding aliasing. First we have the thick wave, that is 7 kilohertz sine wave. On that I projected our 1 kilohertz wave from where 1k came. Fm 7k plus or minus n into 6k. N place 0 7k, n place 1 13k and 1k. I have placed 1 kilohertz Eliezer wave. When it is picking the sample for every 166 microseconds, FSC 6 kilohertz means 1 by 6000 becomes 166 microsecond. When it is picking the samples for every 166 microseconds, there is no mechanism inside the computer that it cannot detect that whether the sample is picked due to original 7k or 1k Eliezer wave. Inside the computer, there is no mechanism. That is the reason to avoid aliasing problem, always we have to do oversampling. Always we have to do oversampling. Okay. This is a better way of understanding aliasing. Not simply saying the component is not there. This is a better way of visualizing aliasing concept. When the computer is picking the respective discrete sample amplitude levels, computer cannot understand because inside the computer there is no mechanism that will differentiate whether it is due to original sine wave or Eliezer sine wave. It cannot differentiate anything for us. Okay. Everyone study this question and answer me. Very funny and simple question. Oh, just a minute. What happened suddenly? Silly fellow. Just a minute. Yeah. The frequency spectrum of a signal is shown in figure. The frequency spectrum of a signal is shown in figure. If the signal is ideally sampled at intervals of 1 millisecond, how the spectrum of sampled signal will be? Decide and tell me which is the correct option. Very funny question, sir. Decide which is correct. It is mentioned sampling time is 1 millisecond. So what is the sampling rate? 1 by TS means 1 by 10 power minus 3, 1 kilohertz. Our FM number also 1 kilohertz. It means in this question Fs equals to FM undersampled or not. Fs equals to FM which is undersampled, automatically resultant spectrum of sampled signal will be constant or not. That is what the third case derivation we have done. Omega naught equals to omega m. Omega naught equals to omega m. We got resultant spectrum as what, sir? Constant spectrum. Resultant spectrum is sampling time 1 millisecond means sampling rate 1 kilohertz. Highest analog frequency FM also 1 kilohertz. Fs equals to FM means undersampled. Don't take emotionally option A, that is critical. Fs equals 2 times FM. In this example, Fs 1K, FM 1K. Fs 1K, FM 1K undersampled. Second option is correct, which is our third case derivation. Omega naught equals to omega m. Third case derivation. Till now, we observed models on how to find the Nyquist rate, one example, few examples, and how to find out the frequencies at the output of sampler. How to convert continuous signal to discrete signal. How to convert continuous signal to discrete signal. Now let us observe the next point. Now let us observe the next point, which is called as signal reconstruction or signal recovery. Signal reconstruction or signal recovery. What is the meaning of this word reconstruction? Is from the sampled spectrum regaining our original continuous spectrum, sir. The process of recovering original continuous spectrum. Original continuous spectrum from the sampled spectrum. From the sampled spectrum is signal reconstruction. The process of recovering original continuous spectrum from the sampled spectrum is signal reconstruction. What are the two valid cases we observed in our derivation, sir? In the derivation we have done, what are the two valid cases we observed is oversampled spectrum is valid. Oversampled spectrum is valid, as well as critically sampled spectrum is also this spectrum valid, critically sampled spectrum, that is also what is the system we need? What is the system we need that will recover back our original spectrum as it is. In our derivation, we assumed reference spectrum as triangle or not. So from these infinite triangles, from these infinite triangles, to recover back our original spectrum as it is, what is the system we need? Try to take a low pass filter of width omega m. Try to take a low pass filter of width omega. To be specific, take peak amplitude as Ts for cancellation of this 1 by Ts, to be specific. Okay. When you multiply x del omega and h omega, we are retaining x omega. But what is the problem with this system, sir? It is an ideal low pass filter. It is an ideal low pass filter or not, which is a non-causal and unstable. Every ideal filter nature is what? Non-causal and unstable. It is used only for mathematical study. It is used only for mathematical study. So as ideal filter design is not possible, we are designing a practical low pass filter that will have filter characteristics like this. We are going to design a practical low pass filter that is having frequency response characteristics. So this is the frequency response of practical low pass filter that is used for signal recovery. That is expecting some more gap compared to omega m. That is expecting some more gap compared to omega m. That is the purpose of providing guard band. Why guard band is needed, sir? Then only design of this practical low pass filter for recovery becomes easy for us. Is it possible for us to use the same filter in the lower case, sir? Is it possible for us to use the same filter in the lower case? If we want to use the same filter in lower case, it is asking replicas frequencies, which is meaningless. So out of oversampling and critical sampling, which is preferred? Oversampling is preferred. Critical sampling is only for our understanding. Critical sampling is only for our understanding. What is the least rate to be maintained? Always will prefer oversampling only. Always will prefer oversampling only. So in technical terms, this filter is also called as anti-imaging filter because it is stopping the repetition of the images. Image means repetition of spectrums. Anti-imaging filter. Transmitting end, we used the name anti-aliasing. Transmitting end, we used the name anti-aliasing. But now it is anti-imaging filter. Both are low pass filters only. Both are low pass filters only. So out of oversampling and critical sampling, which is preferable means oversampling is preferable. Critical sampling is only for our understanding what is the least rate to be maintained. So oversampling has two advantages. One advantage, design of this filter becomes very easy. We don't have any stringent requirements. See the cursor, sir. Oversampling has two advantages. One advantage is design of this filter becomes very easy. We don't have any stringent requirements. Second point, as the number of samples are increased, sample to sample gap is decreased, discrete signal will more appear like continuous signal. Oversampling means increase in the length or not. As the number of samples are increased, sample to sample gap is decreased, discrete signal will more look like continuous signal. One advantage of oversampling, design of practical filter becomes easy. This recovery filter becomes easy. Another advantage is what, sir? Another advantage, as the number of samples are increased, sample to sample gap is decreased, discrete signal will more look like continuous signal. Most important observation you have to make in our discussion is, for signal recovery, what must be the cutoff frequency range of the filter? Here I denoted that as B, where B lies for recovery of our original signal. For recovery of x omega, where B value lies, sir? it is greater than omega m, less than omega naught minus omega m. If you want to recover back our original signal, the cutoff frequency of the filter range is what? Omega m to omega naught minus omega. You take any practical case, we will never take critical sampling. You take any practical case, we will never take critical sampling, sir. Because if you take voice signal, highest frequency 3.4 kilo, but sampling rate practical number 8 kilo we are taking. 6.8 sufficient, but we are taking 8 kilohertz. Audio highest is 20K, but for CD player it is 44.1 kilohertz. 44.1 kilohertz we are choosing for CD player. What happens when you take more number of samples? That is oversampling. One advantage, design of the filter becomes easy. Second advantage, as the number of samples are more, sampling period is decreased. Once the sampling period is decreased, discrete signal will more look like what for us? Continuous signal. Discrete signal will more look like continuous signal. Once the number of samples are decreased, sample to sample gap is decreased. So the discrete signal will more look like continuous signal for us. Okay. This is also called as interpolation. Undersampling is decimation. Reducing the sampling rate is like decimation. Oversampling is like interpolation. Oversampling is like interpolation. Okay. Main observation in our discussion is what? If you want to recover back our signal, what must be the cutoff frequency range for the filter? It must be greater than omega m, less than omega naught minus omega m. Greater than omega m, less than omega naught minus omega m. B is the cutoff frequency for that filter to be designed. B means cutoff frequency. I am representing that as B. B value should lie between omega m to omega naught minus omega m. Transmitting end, we used a low pass filter before sampler. Receiving end, we are using anti-imaging filter after sampler. So this is anti-imaging. Transmitting end, its name is anti-aliasing. Anti-aliasing there, anti-imaging. Both are analog filters only. Okay. Let us make one observation here. Okay. To recover the original signal, we said cutoff frequency must lie between omega m to omega naught minus omega m. Omega m to omega naught minus omega m. Signal reconstruction can be also called as interpolation, because what is the only preferred technique? Oversampling is preferred. Undersampling is like decimation. Oversampling is like interpolation, sir. Oversampling is like, actually this technique is called as band limited interpolation. We are learning in few minutes zero order whole circuit also. Okay, wait for some time. This is called as band limited interpolation. Band limited interpolation. Please answer me this question. A signal 6 cos of 10 pi t is sampled at the rate of 14 Hz. To recover the original signal, what must be the cutoff frequency range? What we mentioned in the previous slides are where it should lie. It should lie in the range omega m to omega naught minus omega m. 6 cos of 10 pi t means what is FM number? 5 heads. What is Fs number? 14 heads. That is given, sampling rate is given as. So for recovery, Fm less than, cutoff less than, Fs minus Fm. Previous slide we said that as omega m to omega naught minus omega m. Means 5 less than, cutoff less than, 14 minus 5. 5 less than, cutoff less than, 14 minus 6 cos of 10 pi t means signal frequency 5 heads, sampling rate 14 heads. 5 to 9. 5 to 9 is the range. Good. Make a try of this model. The spectrum of a band limited signal after sampling is shown in figure. He wants the value of sampling interval. That fellow has given oversampled spectrum for us. He wants to know what is TS number, sir. He wants to know what is TS number. Okay. Compare the given spectrum with oversampled spectrum. Oversampled spectrum is what? First triangle which is symmetric with respect to origin is covering minus omega m to omega m. In our case, minus 100 to 100 means Fm is 100 Hz. It is given in F scale, sir. Minus omega m to omega m means F scale 100. Next, shifted replica starts at 150. Where our shifted replica starts here? Omega naught minus omega m. See the cursor. Shifted replica starts at omega naught minus omega m. That is given as 150 means Fs minus Fm is 150 Hz. So Fs becomes 250 Hz. Nyquist interval is 1 by Fs. 1 by 250 means 4 milliseconds. The first triangle which is symmetric with respect to origin covers from minus Fm to Fm. Next one, 150 to 350 means Fs minus Fm. It starts. That is one style. One style of answering this. 4 milliseconds is the answer. Good. Another style is directly shifted replica is covering what range for us, sir? Directly shifted replica is covering what range for us? 150 to 350. Means it is Fs minus Fm to Fs plus Fm. Middle value is Fs or not? It is covering from Fs minus Fm to Fs plus. As Fm is 100, above 150 we should have 100, below 350 100 means what is Fs number? Above 150 100 50 100 means 50. Any technique, answer is same. Anyway, answer is same. The shifted replica covers from 150 to 350 means this middle value Fs, it is shifted by Fs value or not? Shifted by this. So Fs minus Fm 150, Fs plus Fm 350 means above 150 you should take 100 or below 350 100 means that number is 250. Both ways the answer is same. Both ways. So based on the models we discussed on ideal or instantaneous sampling, what points you have to remember is only 3 points in our discussion review. Nyquist rate meaning is what? Everyone tell me. The minimum sampling rate required is called as Nyquist rate, which is 2 times highest analog frequency or not. That is one observation we have made, sir. Nyquist rate meaning is 2 times highest analog frequency. Second model we observed is how to find out the frequencies at the output of sampler. How to find out frequencies at the output of sampler, sir? Omega plus or minus n into omega naught or Fm plus or minus n into Fs. This is another model we solve. N varies from 0 to infinity. How to find out the frequencies at the output of sampler? The last point is for recovery of x of omega. What is the range of cutoff frequency for the filter? B value should lie in what range? Omega m to omega naught minus omega m. If you want to recover back our original signal as it is, what must be the cutoff frequency range for the filter, sir? Greater than omega m, less than omega naught minus omega m. Entire ideal or instantaneous sampling, whatever we have learned, it depends only on these 3 points, sir. Nyquist rate is 2 times highest analog frequency, first point. How to obtain the frequencies at the output of sampler is omega plus or minus omega n into omega naught or Fm plus or minus n into Fs. For recovery of the original spectrum, what must be the cutoff frequency range? This is the cutoff frequency of the filter. It must be greater than omega m but less than omega naught minus omega m. Greater than omega m, less than omega naught minus. Whatever we have learned till now is ideal or instantaneous sampling, which is not a practical concept because generation of periodic impulse train is not possible. Mathematical enjoyment only. Generation of periodic impulse train is not possible. It is only mathematical enjoyment. For that reason, we are discussing the practical form of sampling, which is called as natural sampling as well as flat top sampling, which is called as natural sampling and flat top sampling. Practical version of sampling. Listen, everyone. What we are doing in natural sampling is we are trying to multiply the same arbitrary signal now not with periodic impulse train, sir. Now we are multiplying the signal with periodic rectangular pulse train. Periodic rectangular pulse train. Instead of impulse, each is replaced as a rectangular pulse. Impulse train is replaced as rectangular. Each rectangle is hardly of 1 millisecond or 1 microsecond duration. Each rectangle is hardly of 1 millisecond or 1 microsecond duration. Once you take product of these two, wherever the rectangle occurs, wherever the rectangle is there, over that portion, original analog signal is retained as it is. Wherever the rectangle occurs, over that portion, original analog signal. It is also called a chopper sampling because we are chopping up the signal. Chopper. Okay, chopper sampling. Why the word natural means? Because it is naturally generated. Whatever the analog signal graph that is there for rectangle durations are, it is retained as it is. That is the reason that word natural. It is naturally generated. The only difference is in our ideal sampling derivation, we have taken this as what? Periodic impulse train. Now it is replaced as what? Periodic rectangular pulse train. For achieving this, the IC we have is CD4016, which internally contains high-speed switching transistor circuits, clippers, because we have to clip the exact portion of the analog segment. Okay, but The disadvantage is the cost of the IC. Not only that, it is very difficult for an analog to digital converter to generate the natural sampler, because converting this natural sample amplitude to digital code, it is different because continuously it is changing its amplitude level. So it is not easy for our analog to digital converter to convert that natural sample amplitude level to digital code in easy manner. One is the cost of the IC, another is the disadvantage. That is the reason we are going for the next one, flat top sampling. Anyway, just listen, sir. I am denoting this as S of t xt into C of t. S of t is the naturally sampled signal. S of t is the naturally sampled signal. Okay. Like we have done a simple derivation there. S of t can be written as xt into C of t is a periodic function. Sigma minus infinity to infinity, any periodic signal means immediately we are writing Fourier series. C of t is a periodic signal. So if I take Fourier transform for this expression, what will happen to the answer, sir? S of omega equals to sigma Cn, signal multiplied by exponential means modulation. Signal multiplied by exponential is, we got fixed Cn number as 1 by Ts in ideal sampling. We got that Fourier series coefficient Cn as 1 by Ts in ideal sampling. But now Cn is not fixed. Cn is not fixed. Everyone see this graph, see the cursor, everyone. I hope you are observing. Okay. What is the time period of this rectangular pulse train, sir? Ts. Minus Ts by 2 to Ts by 2 means Ts. But within the time period, it is covering pulse width of dr0 with amplitude 1. Pulse width of, our job is calculation of Cn. Cn is 1 by T means 1 by Ts. Integral minus d by 2 to plus d by 2. Amplitude 1 e power minus jn omega naught t dt. Everyone see the previous slide. Our time period Ts. Covering pulse width of d, amplitude 1. That only I substituted in Fourier series coefficient definition. 1 by t integral minus d by 2 to d by 2 amplitude. Of course, it is going to retain this answer. Sin n omega naught d by 2 by n omega naught ts. That is not a big deal. Every one of us know rectangle in time domain corresponds to which function in frequency? SAF function. Rectangle in time domain corresponds to SAF function in frequency domain. Listen, sir. In the process of obtaining the frequencies at the output of sampler, just now I stated n can be varied from 0 to infinity in ideal sampling. But now in natural sampling, every n number is not valid. In natural sampling, every n number is not valid. Based on omega naught and d number, means based on the time period of this one and the pulse width, there is a chance this solution may be 0. Suppose in our question C5 coefficient 0, sir. If C5 coefficient is 0, you cannot take omega minus 5 omega naught. Suppose based on omega naught and dn numbers, if C5 coefficient is 0, you cannot take that shifted replica. That is an extra care we have to take in natural sampling. That is an extra care we have to take in natural sampling. See here. So how we are going to visualize the spectrum here means, again if you assume the reference spectrum like triangle only. Again if you assume the reference spectrum like triangle only, the spectrum of naturally sampled signal is going to appear like this. First C0 x omega. C0 into x omega. How I have drawn that? Substitute n place 0, C0 into x omega. If I say substitute n place 1, C1 into x of omega minus omega naught. C1 into x of omega minus omega naught. Next C2 into x of omega minus. Why the triangle height is gone decreasing? Because it is extra multiplied by SAF function or not. Original spectrum amplitude is multiplied by SAF function. What is SAF function nature? As frequency is increasing, magnitude is gone decreasing or not. So roughly this is the spectrum of naturally sampled signal. Here also the frequencies at the output of natural sampler is omega minus n omega not only. Same thing, sir. Or omega plus or minus n omega naught. N can be varied from minus infinity to infinity, but what valid n number is decided by what? After calculation of Fourier series coefficient only, you can say what is the valid n number. After taking valid, after calculating the respective Cn coefficient, exponential coefficient only, you can say which are the valid shifted replica. Blindly you cannot take everything. Disadvantage is what? For this, it is difficult for an ADC to convert natural sample amplitude to digital code. Why it is difficult? It is gone changing its amplitude level. Based on the curvature of the analog signal, we require still perfect circuitry. One is cost limitation of this IC. As it is continuously changing its amplitude level, more number of bits must be used. That is another disadvantage of natural sampling. Okay. The only difference between ideal sampling and natural sampling is instead of periodic impulse train, what we replace? Periodic rectangular pulse train. Generally, each rectangle is of 1 millisecond or 1 microsecond duration. Finally, when you are finding the frequencies at the output of natural sampler, they are also decided by same term. But which is the valid shifted replica? Which is the valid shifted replica? That is decided by what? After calculation of Cn. Why in the spectrum the triangle height is gone decreasing, sir? Because it is extra multiplied by SAV function or not? It is extra multiplied by SAV function. Even our competitive exams are going on from so many years. Till now, only one gate paper, very old gate paper, a question is framed on natural sampling. Day before yesterday only I mentioned with you, very less practical questions you will get. Our emotion is ideal sampling only. Maximum, if you see old papers, you are going to find out ideal sampling only. In the very old gate paper, sir, one time this question was asked. Only one time. First everyone see. We got Cn as SAV function. Because it is rectangle Fourier transform. So if you assume again original spectrum, band limited spectrum as triangle, this answer extra multiplied by SAV function. That is the reason triangle amplitude is gone decreasing. But which are the valid Cn coefficients that you have to calculate for a given example? Then only you will know what is the valid n. Let us see the problem now. This is the example asked. Now that fellow has added two sinusoids, 2 cos 800 pi t plus cos 1400 pi t. X of t is sampled with rectangular pulse train. He wants what are the frequency components that are present in the range 2.5 kHz to 3.5 kHz. Sampling time mentioned as 1 millisecond. Sampling time 1 millisecond means what is the sampling rate, sir? 1 kilohertz. Sampling time 1 millisecond means sampling rate. As a rectangular pulse train is given, first our job is calculation of Cn. This is taken as reference interval, but rectangle covers from minus T0 by 6 to. Everyone first calculate Cn, then we will see the rest of the story. First everyone calculate Cn, sir. 1 by T0. Integral covers from minus T0 by 6 to T0 by 6. 3 is the amplitude e power minus jn omega naught t dt. First everyone calculate the Fourier series coefficient. minus T naught by 2 to plus T naught by 2 reference, sir. But it is covering minus T naught by 6 to T naught by 6 amplitude 3 multiplied by exponential. Tell me the simplified CN answer, everyone. Tell me the simplified answer. Two sin n pi by 3 by n pi. That answer you will get after simplification. 2 sin n pi by 3 by n pi. So CN answer will be definitely 0 for which harmonics? N equals to 3, 6, 9, etc. N plus 3 sin pi, n plus 6 sin 2 pi. It is not equals to 0 for which value, sir? 0, 1, 2, 4, 5, 7, 8 like that. 0, 1, 2, 4, 5. A periodic signal has only positive amplitude level means 100% DC is there or not? 100% DC will be. Everyone see here. FM1 is given as 400 Hz, mean 0.4K. 1400 pi means FM2 is given as 700 Hz, sir. Mean 0.7K plus or minus, you can say plus or minus. So frequencies at the output of natural sampler. Frequencies at the output of natural sampler. How many combinations now? FM1 plus or minus N into Fs. FM2 plus or minus N into. Which are the valid numbers? 0, 1, 2, 4, 5, 7, 8 like that. FM1, FM2 are 0.4K, 0.7K. Fs 1K. These are the N numbers that are valid. Tell me what frequencies are present within this range out of the 4 options. Addition I left for you. Do that enjoyment and tell me only addition. FM1, FM2, 0.4K, 0.7K. Fs 1K. Valid N number also you know. Addition I left for you. Do that addition and tell me. Out of the 4 options, correct answer I want. Think. Just do substitution. Addition, bacha things I will not do. 1 plus 0.4, 1.4, 1 plus 0.7, 1.7. That enjoyment you have to do. I am giving time for you. Out of the 4 options, tell me which is correct. Don't take emotionally. N plus 3. N plus 3 not valid. N plus 3 will create 3.4, 2.6. Gone. Don't take N equals to 3, sir. It is not valid. I have neatly mentioned here 0, 1, 2, 4, 5, 7, 8 only. If you take N value as 3, it will create for you what? 3.4, 3.7 like that. 3.4, 2.6 like that. Correct answer is the last option 2.7 and 3.3. That is the correct answer. 2.7 and 3.3 because he has asked in which range. Find out the frequency components in the range 2.5 kilohertz to 3.5 kilohertz. Do that simple addition. N plus 0, 0.4, 0.7, N plus 1, 1.4, 1.7 like that. Solve it. He wants in the range 2.5 to 3.5. Last option you will get. but don't substitute emotionally n as 3. N equals to 3 is not valid in the question. That is what just now I stated. Frequencies at the output of natural sample is also decided by same term. Valid n is decided by what? Calculate Cn. First Fourier series coefficient you calculate. Then only you will know what is valid. I hope addition is completed for everyone. Addition of the numbers. How we got 3.3 are a bacha, n plus 4 substitute. FM2 can be minus 0.7. This can be plus or minus. I mentioned in the beginning only. They are impulses plus or minus. 4 minus 0.7 is 0.33 na. N plus 4 substitute. FM2 plus or minus 0.7 means 4.7 is there. 3.3 is also there. Enjoy karo. .4 valid. How will get 3.4 bacha? N plus 3 is not valid na. If you take n plus 3, then only 3 plus 0.4 is 3.4. Arey, kahan se? For n equals to 3, what is Cn answer? 0. If that shifted replica is not valid, sir. Negative will be there, yeah. Arey, funny fellow. Cos means two impulses, na. Both positive frequency, negative frequency will be there. What is there? No problem. Cos function or sine function will have impulses in the spectrum or not. If plus 3.3 is there, minus 3.3 must be there. How will recover back original real signal? When you have only plus 3.3 without minus 3.3, you cannot recover original signal. Na? Definitely it will be there. Okay. Let me discuss the next form of sampling, flat top. Flat top sampling. Listen everyone. What actually we are doing in flat top sampling is, without maintaining this type of curvature, after picking every sample, we want to maintain flat level. Pick the sample, take flat level. Pick the sample, take the flat level. That is the reason it is called as flat top sampling. Roughly I am showing on naturally sampled signal only. After picking the sample, try to maintain flat level. Here also after picking the sample, maintain flat. That is the reason that word flat top sampling. Listen sir everyone. How you are going to get the flat top sampled signal is, when you are trying to pass the ideally sampled sequence, for derivation purpose only I am representing this as continuous impulse. Inside the computer they are stored in discrete form. For derivation purpose only I am representing as continuous impulses. Once this signal is passed through a rectangular pulse of width t, whatever the output you are getting, that is called as flat top sampled signal, which is x del t convolved h of t. Input down, system down, get the output means convolution. Blindly here convolution property of impulse. Xt convolved del of t minus t naught is x of t minus t naught. That property we should apply, sir. Everyone see here. How we are going to get that flat top sampled signal is, if I convolve the rectangle with impulse at origin, whatever the weight of the impulse is there, that becomes the amplitude of the rectangle, sir. Whatever the weight of the, if I convolve the same rectangle with impulse at TS, it is shifted by TS units. It is shifted by, similarly on the left side. Similarly on the, this is the flat top sampled signal graph. For getting this graph, which property we use means convolution property of impulse. So for getting flat top sampled signal, we are using a simple circuit called as sample and hold circuit. Sample and hold circuit, which contains two FET switches. Two FET switches followed by capacitor. Followed by capacitor. S1 is like sampling switch, S2 is like discharging switch. S1 is like sampling switch, S2 is like discharging switch. Everyone see here? Don't get emotion, observe here. When S1 is on, S2 is off, capacitor charges to peak amplitude for certain duration. See the cursor. When S1 is on, S2 is off, capacitor charges to peak amplitude for certain interval. When S1 is off, S2 is on, capacitor is going through discharging path for certain interval. By using this simple sample and hold circuit, we are in a position to get that signal where the cost is negligible. Assume in the market FET switches are of 1 rupee, capacitor may be less than 1 rupee. For fun, I am saying maybe less than 5 rupees we require. But the previous IC number CD4016, which I mentioned, is very costly. Wherever simplicity is there, problem will come automatically. The circuit may be simple, sir, but here we are facing a problem called as aperture effect. Aperture effect. What is aperture is, actually we want curvature in the graph. But what we are doing here, blindly maintaining constant amplitude or not. How to understand this word aperture? Let me draw the flat top sampled spectrum, then you will understand. Let me draw the flat top sampled spectrum. Everyone see here. What is the Fourier transform of this expression I can take? S of t I have written as x del t convolved h of t. So what is the Fourier transform I can take? S of omega equals to x del omega multiplied by h. S del omega is same as our original derivation. 1 by ts sigma x of omega minus n into omega naught extra multiplied by h omega. X del omega, spectrum of ideally sampled signal, same formula, 1 by ts sigma x of omega minus n omega naught into h. What is the meaning of h omega, sir? Fourier transform of this rectangle. Everyone tell me, if I take a rectangle from minus t by 2 to plus t by 2 with amplitude 1, what is the Fourier transform answer we are writing, sir? T sync omega t by 2 pi. T sync omega t by, but in our case, that is right shifted by plus t by 2 units. That is right shifted by plus t by 2 units means it is original spectrum extra multiplied by e power minus j omega t naught. Okay. So by maintaining this constant amplitude, now we have introduced sync distortion. In e power j theta, phase angle is minus omega t by 2, not a big problem. Distortionless condition is we want linear phase spectrum. That is not a big problem, but we introduced magnitude distortion. So how to explain this aperture effect? Everyone see here. X del omega valid spectrum is oversampled spectrum, repetition of triangles. Because under signal reconstruction, we checked oversampled spectrum is valid or not, sir. I am taking that as it is. X del omega. Now x del omega is extra multiplied by mod h omega. Now x del omega is extra multiplied by mod h omega. Don't bother about phase angle. Chhod do. What is mod h omega nature, sir? Sync function nature. As frequency increases, the magnitude is gone decreasing up. once you multiply these two, you are going to retain the flat top sampled spectrum that will look like an inverted bowl. After multiplication of both the spectrums X del omega into mod H omega, you are going to retain the flat top sampled spectrum like inverted bowl. Inverted bowl. See everyone here. So what happened here? Compared to the lower frequencies, at a higher frequency, signal information is lost. But what is the target in sampling? You go for any frequency shift, you have to retain information as it is. You go for any frequency shift, you have to retain the information as it is. But compared to lower frequencies, at higher frequencies, information loss occurs. Why it is lost? Because of the sync distortion we introduced. Why we got sync distortion? As we have maintained constant amplitude level. See the link. Compared to the lower frequencies, higher frequency information loss occurred. Why it is occurring? Because of the sync distortion we got, sir. Here we introduced sync distortion. So, why we got sync distortion? As you have maintained constant amplitude level. Then what is the cure? How to reduce this problem? If I go on increase the width of the main lobe, this is like a curvature. If I go on increase the width of the main lobe, roughly this graph may become constant and we can recover our triangles as it is. But it is not in our hands because the width of the lobes is controlled by which parameter here? T. T is also controlling. If you want to take rectangular pulse of width 1 second or 1 microsecond, you can take. It is not our body width. Rectangular pulse of short duration. So that technique is not possible. Go on increasing the width of main lobe is not possible. Then what is the cure is? Flat top sampled signal is passed through the inverse block 1 by mod H omega. Whatever the distortion that is introduced now, sync distortion, to undo that effect, take the opposite characteristics. This is called as equalizer. Process of correcting channel distortion is called as equalization. When you pass this flat top sampled signal spectrum through 1 by mod H omega, what you are left with? Repetition of triangles. So the circuit may be simple in flat top sampling. Apart from that, what extra you need? Design of equalizer. Equalization means process of correcting channel distortion is called as equalization. Process of correcting channel distortion is called as equalization. Process of correcting channel distortion. Process of correcting channel distortion is called as equalization. Whenever you are designing a sample and hold circuit, automatically you are in need of designing equalizer. That is what we are learning at ISI to avoid intersimple interference, ISI problem. We are designing raised cosine filter, zero forcing equalizer, like that or not? Respond everyone. To avoid ISI problem, we require raised cosine filter, zero forcing equalizer or not? Come on, sir. What is aperture meaning is whatever this flat top sampled spectrum shape is there, that is decided by the parameter T. Rectangular pulse of width T, that is deciding the shape of the flat top sampled spectrum. So compared to the lower frequencies, higher frequencies, information loss occurs. To avoid that, flat top sampled signal is always passed through inverse block, which is called as equalizer. So equalization general meaning is what, sir? Process of correcting channel distortion is called as equalization. Okay. So to cancel aperture effect, why the word aperture means? It is representing rectangular pulse of width T. To cancel aperture effect, flat top sampled signal is passed through equalizer is passed through equalizer 1 by mod h omega. 1 by mod flat top sample signal is passed through equalizer 1 by mod h omega. Okay. But another important observation you should make here is this rectangular pulse, whatever we have taken, is called as ZOH circuit, zero order hold. ZOH means zero order hold. Why that name? For a constant signal, what is the slope, sir? For a constant signal, what is the slope? 0. At 0, it is taking peak amplitude of 1, holding that for t seconds. That is the reason zero order hold circuit. Let me explain that point. Zero order hold circuit. What is the physical form of zero order hold circuit is what it contains. Delay followed by summing point followed by an integrator. This is the physical form of zero order hold circuit. What is the input we have applied here, sir? For that circuit, what is the input? Different stream of impulses, sir. Different stream of impulse. If I give del t here, what is the output of the summing point? Del t minus del of t minus t. Integration of impulse, every one of us knows step function. Ut minus u of t minus t. It is a rectangle from 0 to t. It is a rectangle from 0 to t. So instead of this rectangle, this is the internal circuit you have. Next time what you will transmit del of t minus ts, automatically it is creating this graph. When you transmit del of t minus ts through that one, it is creating shifted version of that one. How this zero order hold circuit can be converted to first order hold? First order hold means RAM. If I convolve the rectangle with itself, shape is triangular. If I convolve the rectangle with itself, shape is triangle, that is called as first order hold circuit. You try to cascade this system with itself. You try to cascade this system with itself, that is called as what? First order hold circuit. Now just recollect why we learned step interpolation, zero interpolation, linear interpolation, all these words we used. All these words used. In natural sampling, more loss will be there compared to flat top sampling, sir. In natural sampling, more loss will be there compared to flat top sampling. Here loss will be less because we are using a equalizer circuit. Why I mentioned zero interpolation, step interpolation, linear, now you can understand. By using a zero order hold circuit, we can do which interpolation? Step interpolation. If I cascade this system with itself, it becomes first order hold. Let me give a clarification on that point also. Listen everyone. Suppose I have sampled form of the signal like this. If I pass this through a rectangular pulse means zero order hold circuit, how the output graph is going to appear means it is going to appear like this. Due to this impulse, this rectangle. Due to this impulse, this rectangle. This is the output of zero order hold circuit. If I pass the same through first order hold circuit, sir. If I pass the same signal through first order hold, the graph may be roughly appearing like this. The graph may be roughly appearing like this. So this is our zero order hold circuit called as step interpolation. This is first order hold circuit called as linear interpolation. In our first classes, we studied only numbers, but how they are physically possible from the sample form, how to reconstruct the continuous signal means we may require zero order hold or first order hold. Still our competitive exams have not gone to that level, don't be tense. But especially for instrumentation fellows, the favorite question is always, what is the transfer function of ZOH circuit? Transfer function means Laplace of this one. What is the Laplace transform of ut minus u of t minus t, sir? 1 minus e power minus st by s. So many times in the gate paper, this is asked for instrumentation bachas. He will neatly mention what is the transfer function of ZOH circuit. He will not give this graph or this shape for you. He will not give this circuit or this. Directly you are in a position to remember. Listen, sir. Flat top sampling, we try to pass ideally sampled signal through a rectangular pulse that is called as zero order Hall circuit, which is giving this graph. All the shaded portion is the error, aperture effect. How to cancel that means we are using a equalizer. That is what I have shown in the flat top sampled spectrum. Over sampled spectrum is multiplied by mod H omega. Means we introduced sync distortion. How to undo that effect means use a equalizer 1 by mod H omega. Don't have a wrong thought, always rectangular pulse is used. That is what this last slide. You can use triangular approximation. In that case, problem becomes sync square. Depending on the output graph, you want to recover that form of whole circuit. You did not get any mathematical question on flat top sampling till now, only 2 theoretical questions. Flat top sampling problem name is what? Aperture effect. How to cancel aperture effect means we should design equalizer. Flat top sampling problem name is aperture effect. How to cancel aperture effect means equalizer. This is what in communication pulse amplitude modulation, PAM. This is what in communication subject we are saying as PAM, pulse amplitude modulation. Okay. Why the name zero order hold means for a constant signal, what is the slopes are zero. At zero, we are taking peak amplitude of 1 till t seconds it is holding. Till t seconds it is holding. That is the reason zero order hold. How to convert zero order hold to first order hold means you try to cascade the system with itself. If you cascade the system with itself, it is convolution of two equal length rectangles that will look like a triangle only. Convolution of two equal length rectangles means triangle or not. In the signal reconstruction, what type of shape you are expecting, that is unknown. If you want constant amplitude level, you go for zero order hold. If you want ramp type, you should go for which circuit? First order hold circuit. Don't take tension about the last one. You remember two things. Flat top sampling problem name is aperture effect. How to cancel aperture effect means by taking an equalizer. By taking equalizer. Equalization general meaning is what, sir? Process of correcting channel distortion is named as equalization. Process of correcting channel distortion is equalization. Why you have to convert, bacha? Why bola na? Why you have to convert means if you want ramp type graph, this type of graph, so zero order hold circuit must be replaced as first order hold. If you want constant amplitude, zero order sufficient. If you want ramp type, then you require first order hold. Depending on the requirement, we have to use that circuit, sir. Okay. Flat top sampling can be easily achieved by sample and hold circuit, but problem is aperture. To cancel that, design equalizer. We have to design equalizer. So we discussed 3 forms of sampling for band limited signal: ideal, natural, flat top. In your examination, till now only ideal sampling happened. Natural flat top, natural one time flat top, even single question was also not touched in the gate paper till now. This is band limited sampling. Okay. For today, I am stopping because continuously I am also speaking. Tomorrow is a holiday. Happy Independence Day to everyone. Enjoy your time. Make a review of the concepts which we learned today. So in the next class, I will discuss sampling of band pass signals. After that, we are going to start Laplace transform. After sampling of band pass signals, we are going to start Laplace transform. As I am speaking continuously today, hardly 2-3 fellows I will give chance. Okay, for doubts, not for everyone, only 2-3 fellows today. Don't get emotion, rest of the fellows. Happy Independence Day, enjoy at home. Take rest. Continuously are watching the screen for so many hours. Take rest, sir. All the best. Okay. Sunday timings are known to everyone. 2 o'clock sharp. 2 o'clock. 2 o'clock we are going to start on Sunday. Okay? Enjoy karo. Bolo. Tell me. Voice is not audible. Voice is not audible yet. Hello, bolo. I'm not getting your voice here. Okay. Yes.
So in page number 18F, 20F, sorry.
20?
Yeah. So here we took the limits of n from 0 to infinity, but in the previous question we also considered -1 values.
What is there in the slide and what you are asking? Tell me.
Okay, 18F.
You said 20F?
Sorry. Tell me. So in this question we took the limits from 0 to infinity for n, right? Like we considered in the previous question. But in the question after this, we considered from 0 to infinity. We did not consider.
It is plus or minus, Amma. Plus or minus means if 45 is there, minus 45 will be also there.
So I'm talking about the n value. We are taking.
That's what. Previous slide I solved for both positive and negative and either. Dekho, n equals to plus 1 minus 45, n equals to minus 1 plus 45. Both are there.
Yes, sir, but in the next question, 19F.
Hey, here there is no need of taking any harmonic because you are retaining plus or minus 45. Where is minus 45 here? Cos minus theta is cos theta only, na? Cos minus theta is cos theta, not cos of minus 45. 45 t means cos 45 t only.
So in the next question, 19F, we took the limits from 0 to infinity. We did not consider n equal to minus.
Why middle plus or minus I have chosen?
Sure.
That is the reason n can be both positive and negative. Now, instead of saying n varies from minus infinity to infinity, I have made plus as plus minus. Both signs are included. What is that?
And so in 29F.
Tell me.
So in here you said that compared to lower frequency, higher frequency information loss occurs.
Last triangle which I have drawn, information loss occurred or not? But what is targeting sampling? You go for any shift, we should recover back our original triangle as it is. Why this loss occurred? Because of the sync distortion we got. How to avoid sync distortion? Use a equalizer. If you use opposite characteristics, we studied invertibility and inverse system. If you take opposite characteristics, you are left with repetition of triangles only.
Yeah, thank you.
Another.
Sir, 5F.
5F. 5F. Tell me.
Sir, in this question, from starting we can apply frequency shift operation, sir, because we know at e power minus 2 omega.
What for you require frequency shift? You are finding out energy. What for you need frequency shift?
E power some value is in also, so I thought we can apply that.
There is no need. What is the need of frequency shifting? You are calculating anyway modulus of y omega na for energy. Mod x omega, mod y omega.
Yes, sir.
What is the need of frequency shift there? It is not affecting anything for you.
Okay, sir. Sir, 15.
Tell me. 15 I opened.
Sir, here D I did. Sir, D I didn't get, sir. How?
What is signal frequency? Already Nyquist at omega naught means what is signal frequency, sir? Half of that. So highest frequency of signal omega naught by 2. Cos function, what is the frequency you have omega naught? What we have done in the previous question, cos into cos means a plus b, a minus b style.
Yes, sir.
That way, if you do addition, it is highest, not 2 times that is Nyquist rate. Add the numbers, add the values, omega naught by 2 plus omega naught is highest, 2 times that is Nyquist rate, na?
Okay, okay. Sir. Okay, sir. Sir, one more doubt is 18th.
Huh?
18th.
Tell me.
Sir, 18.
18 only.
Sir, here how we got half? I am not getting, sir.
Array, xt cos omega naught Fourier transform is what? Recollect. Yesterday all our discussion went on that only. X of omega minus omega naught plus x of omega plus omega naught divided by 2 is not there.
Okay.
Tell me.
Okay. Yes, sir.
Communication subject is over.
No, sir.
For you.
No, not over, sir.
Okay, chhod do. Because some fellows have completed all their communication without knowing that point means I want to scold you. Okay, chhod do Ash. Right.
Happy Independence Day, sir.
Yeah. Same to you. Same to you. Same to you. Your voice is breaking here today. Same to you. Bye.
Thank you.
Hello.
Yes, sir.
Sir, PS1F.
Oh, starting only.
Sir, I lost my network at that particular.
Achha. Nothing is there. Yesterday's formulas I have discussed. Tell me.
Okay. So what you have done?
Nothing. I explained yesterday's formula. Yeah.
And 2F, sir? 2F?
2F, I started a problem. Filter response given, input given. I asked for output spectral density means input spectral density multiplied by magnitude whole square. Second bit is show that total energy in the output is 1/3 of input energy. If you know output spectral density, how to get output energy area under the curve? We got it.
Okay. No more problems.
Right.
Happy Independence Day.
Same to you.
Hello, sir.
Ah.
Sir, in page number 22F, sir.
23. Yes, ma.
In that you said the oversampling has advantage. The second point, how number of samples increases, sir?
Oversampling means suppose instead of 20 kilohertz, if I take 40 kilohertz, what is TS value? 1 by 40 kilohertz means 0.025 milliseconds. N is multiple of TS. Automatically sample to sample gap is decreased or not?
Okay, sir.
It will appear like more like continuous signal then.
Okay. Sir, a problem, sir, here input channel is a band pass signal. Y of t is given as one multiplication of two cos signals.
Single frequency is given means it is due to sinusoid only. A non-sinusoid contains multiple frequencies.
No, sir. A problem asking about group delay and phase delay, sir.
Where?
In a problem input.
In that you see carrier frequency. If you take carrier frequency common, that is called as phase delay. Message signal frequency you take common, that is called as group delay.
I didn't get, sir.
That output 1 by 10 into cos of 10 power 6. That expression, cos into cos.
Yes, sir.
In that first frequency, cos of 10 power 6 or something will be there. If you 10 power 6 is carrier frequency,
yes, sir.
That if you take 10 power 6 common, that is phase delay. Whatever the extra delay is there, that is phase delay. Next custom 100 frequency, take that 100 common, group delay, you will get 10 power minus 8.
Yes, sir. I did like that. Thank you.
Sir. Enjoy.
Sir.
Sir.
Hello, sir.
Bolo, sir.
Sir, I have a doubt of one JTO question, sir, that about equalizer. Sir, they have asked the magnitude response of an ideal equalizer.
Last magnitude response बोले तो उसका opposite ले लो. मैं जो कुछ बताया अभी t sin omega t by 2 पे expand करो.
Yes, sir.
Opposite ले लो.
अच्छा, उसका opposite लेने से हो जाएगा उसका.
वही है ना 1 by mod h ओमेगा बोले तो।
अच्छा, और एक और सा प्रॉब्लम है सर, ये इसरो का क्वेश्चन है, इसमें बोला है सर पीरियोडिक फंक्शन ऑफ ए हाफ वेव सिमेट्री इज नेसेसरली, उसमें क्या आंसर होना चाहिए?
No, it is not necessary.
हाँ भाई सर,
It is not necessary.
क्यों सर?
Half wave symmetry it is not compulsory for every signal because the original signal may be odd signal also.
Okay, odd zero or even zero, that means neither odd nor
Hello?
even. It's that means neither odd nor even.
Yes.
Okay, sir. And
Okay.
one more thing, sir. We will study digital filters here, sir, and signal systems.
I will teach everything. Once the syllabus is changed on that day only, I mentioned I will teach everything. I will not leave anything. Instrumentation fellows are there. For them, I have to teach.
Okay, sir. Okay, sir.
I will teach Laplace also. Everything I will teach. Whatever I have written in the first class. Apart from that, extra topic also I will teach for easy.
Yes, sir. Because it is helpful in other exams also. Like IAS, sir.
I will teach here. I will not show. I will
Oh,
not
yes,
teach
sir.
anything.
Okay, sir. Okay, sir.
Enjoy karo.
Hello, sir.
Hmm.
Sir, 28F, sir.
28.
Sir,
I'm at
this one
28.
only, sir. Sir, since impulse sampling with impulse signals is not possible, that's why we are coming to flat top now, sir.
Yes.
Sir, again here
this
we
I
are
have taken only mathematically here. This in its physical form inside the computer. What suppose this number is 2, it will store it as 2 only. For doing this derivation, I have taken. That is what I mentioned. For mathematical derivation only, I have chosen. It is inside the computer. It is stored as that sample only, 2 only, discrete sample only.
Okay, sir.
Chalo. Over.
Yes, sir.
Hello, sir. Hello.